Hey everybody, welcome to .NET Day of Agentic Modernization. We have a jam-packed schedule of great content today that covers all sorts of agentic modernization with .NET. But seriously, what is in a name? .NET Day of Agentic Modernization. Well, the .NET part, that's easy. But let's talk through the agentic modernization part a little bit. Agentic, well, that can mean a couple different things, and today we're going to have sessions that cover the gamut of them. We're going to talk about developer tooling, we're going to talk about things like SRE, and we're also going to talk about building the agents yourself. So you're going to see how some agents in developer tooling can really help you upgrade applications from legacy.NET and even migrate them over to Azure. And then Azure MCP. Now, this is an amazing tool that helps you with like infrastructure and coding all within Visual Studio. And actually, I used it the other day to migrate, well, actually, I migrated a Node.js app from, I had no idea what I was doing. Got it all up to Azure, not knowing what I was doing, using the Azure MCP server. And you're going to see actually how Azure SRE agents can help you get ahead of incidents and issues before they're even reported. So these are all agents kind of running for you, but we're going to have sessions on how you actually build agents yourself with the new Microsoft Agent Framework, including using durable functions. And of course, we're going to talk about building secure agents as well by using Azure SQL and Redis. So agents in dev tooling, agents that help you create apps, and developing agents yourself, all today. So let's start going and kick it off with GitHub Copilot App Modernization.
Cool. Hi, everybody. I'm Brady Gaster, and I'm going to start the day off here. So we're going to talk about choosing your own app modernization adventure with GitHub Copilot App Modernization, kind of the star of the show for at least part of the day. I think we're going to be talking about some other stars of the show, like Agent Framework, which is over here, et cetera, et cetera. So without further ado, let's go ahead and dive in. So I like to work on tools, and one of the things that I've done over the years is to upgrade a lot of different applications, both my own and those that customers have brought me and asked me to help them with, to get them either upgraded so that they can get them into the cloud or make them more performant. In a lot of cases, they also wanted to upgrade different components that they were using. We'll talk about a little bit of that today. But the start of that was usually they wanted to upgrade their their framework version from version X to version Y. The interest in AI throughout our industry has really renewed interest in all of this app modernization stuff. Why is that? Because a lot of the old tech, a lot of the legacy tech, you can't connect it to AI. It's a lot more complicated to connect it to AI, and it might not perform, up to snuff with where we need it to in terms of GPU performance and whatnot. So a lot of folks' first step in that modernization journey is actually, bringing their app into the future, using a later version of their stack, using a later version of dotnet, which we'll see here in a moment, so that you can actually harness some of those newer SDKs and APIs that legacy apps can't deal with. At the same time, we've got a lot of different reasons why there's a lot of challenges for modernizing apps. The first one, obviously, the technology. The cost of increased technical debt, goes up all the time. This is something that we've talked to a lot of different CIOs about. We know that the costs are rising when it comes to them having to maintain these, legacy applications. When we talk about memory and footprints in a moment, you'll see one of the reasons why is probably the apps are expensive to just keep running. Second thing is going to be skills. I've been around in the .NET community for a really long time. We won't talk about it. I was looking for the visual iterative box earlier today to kind of put it up here as a prop. Got my old friend here instead. But the idea behind all these old apps is it's really hard to find people who, like me, know that old tech or who want to work on that old tech. Most people want to, continue to work on, the newer and the hotter tech. So it's really hard for folks to find people who have those skills and, want to continue to invest in those skills. Last part, resources. The developer focus. Devs want to move forward. So if you want to talk to a dev about, hey, I want to pay you the same amount of money to work on something exciting versus something, that you've worked on for the last 20 years, they're probably going to take option A. Devs want to work on more exciting stuff. So we want to make it more exciting for you, and we want to make it easier for you to get from where you are to modern. Now, I guess the first question we want to ask is, why would you want to upgrade your app? Why would you want to upgrade your app from .NET X to .NET Y? In a lot of cases, you don't need to. In a lot of cases, you've got applications that are churning along just fine. I've got colleagues out there that still have classic ASP applications that they're maintaining. It's shocking, but they're still running just fine. They don't need to upgrade them. They're not getting any additional users. There might be internal apps, so they'll have the opportunity to move to things like app service managed instance, which we'll hear more about later on today. But in a lot of cases, you want to increase the performance of those applications for a myriad of reasons. You've seen this slide before. In 2023, I used this slide at Build to talk about, I think that was the .NET 8 upgrade we did at that point, and talking about cloud native. And this slide was specific to native AOT. But really, the message holds true for modernizing your apps today. Why would you want to do it? First rule, you want to have reduced size on disk. You want each instance of your application to run smaller. Why do you want it to run smaller? Because hopefully you're running it inside of a container and you've got 10, 20, 1,000 instances of your application running on one server. So that's the first reason, density. If you can make the application smaller, then it's probably going to be, you can get more instances of it running. Second thing is going to be, in 2023, and with modern apps in general, that you're going to have faster startup times. So your application is going to go from not running to running in a very quick period of time. It's also going to run faster and use fewer resources. That's really important because you're going to pay for that startup and you're going to pay for that resource utilization. You pay for CPU and you pay for RAM when you're running in the cloud. That's something really important to think about when you're thinking about having your applications run up there, which is why you would want to upgrade your app. Let's talk about this in terms of numbers. So I've got a sample app that I'm going to use today. It's not a really complicated app, but I took the application up in Visual Studio, opened it up, and I went ahead and I ran a series of steps, kind of the user scenario. It's a shopping cart app. You'll see me use it here in a moment. And the idea is I wanted to run this application under the profiler in 4.8.1, and then I wanted to upgrade the application to .NET 10 and rerun it under the profiler again and see what kind of difference we could get. There were lots of differences across the counters we won't go into today. But when I did take a look at the memory, you can see here that the process memory of the framework app was around 400 megs, and the process memory of the .NET 10 app was around 60 megs. What that tells you is that we basically had an 84% improvement in the application and got a 6%, over 6%, almost 7% more memory efficient app. That's what you get when you upgrade your app, and that's why we talk about upgrading your app, because we want you to be able to run more instances of your apps in the cloud. So without further ado, let's go ahead and talk about what that would look like. I'll go ahead and hit escape here and get over to my dev box. Now you saw me do this at .NET Conf during our wonderful keynote with Kathy, but the idea behind this application is I've got a front-end application that's a product catalog, and I've got a WCF service on the back end. No database yet, we're working on that, just got some static data for the moment. But if I run this, you'll see that I'm gonna fire up that WCF app, and then I'm gonna fire up that front-end app as well, because that front-end app needs to talk to that WCF app to run. It's gonna go ahead and spin up. You'll see here, I've got that WCF test client from back in the day running right here to show me that my WCF app is indeed running. And then you'll see here that I've got the product catalog running. So I'll hit add to cart. And you can see that as I add the items to the cart, you'll see that we're actually getting the items in the cart. If I were to go over here and do a checkout, you'll see that that's gone ahead and done a order submission. Now that order is going to get sent into a Microsoft message queue, again showing my age and the tech that I like to use back in the day. You'll see there's that first order that landed in our local queue. But what I want to do is I want to upgrade this to the later version of .NET. Now I'm not going to let this whole thing run, but the way I'll start the process is I'll right-click on the solution and I'll select Modernize. You can do this at the solution level or at the project level, just to point out. You'll see that I have a few options over here. Upgrade to a newer version of .NET, the newest, the latest, the hottest, the 10. And then got the second one we'll talk about here in a moment called Migrate to Azure. We'll get to that one momentarily. I'm going to go ahead and select Upgrade to a newer version of .NET, and I'm going to click Enter down here. And what it's going to do is it's going to scan my application. It's going to figure out where I am and what kind of version I've got and what the topology of the application is going to be. And then it's going to walk me through the process of kind of coming up with a plan. So the first step is going to be it wants to go ahead and create a different branch for me. I've already got that branch ready. I'm going to tell it a different branch. I'm going to say change the branch to .NET 10 upgrade because I've already got the name of that branch, and continue. And what it will do now is it'll actually go ahead and create that new branch. Hopefully it'll name the branch for me. We'll see the main drop there because it's going to go ahead and do .NET 10 upgrade. You'll see down at the bottom, it's created that branch for me here. And now it's actually going to do a little bit more analysis, and it's going to present me with essentially a markdown plan. That plan will actually give me an opportunity to kind of review and see what's going on, see what's actually going to happen. And I'm not going to run the plan right. Actually, I'll go ahead and hit continue. I'll let it continue for a moment. What it's going to do is it's actually going to upgrade this entire solution all the way through to .NET 10. Now I've already run this. Now there's the plan. There we go. It's already ahead and upgraded. It's popped up in the plan in my Markdown editor. And what I can do is I can scroll through this. I could look in the preview mode if I wanted to, and I could actually see all of the steps that it wants to perform before I actually do those steps. And if I want to, I could actually change it. Now, just something to point out. I could go directly into this Markdown file if I want to, but I could also go right here into my chat and just say, hey, don't do this one thing that you're suggesting you're going to do this instead. So I could interact with Copilot here a little bit further if I wanted to and get that plan a little further along. Now, I'm not going to run the rest of this plan, but what I will do is I'll go over here to this app because I've already got it done, and I'm going to go here to my upgrade to .NET 10 branch, and I'll click on this button right here that says compare. And you can see we got 91 files changed, and if I were to scroll through them all, you'll see it does things like upgrading to the SDK style format. That's going to be the first step. It's going to update all of the WCF packages to use core WCF. In this case, we go ahead and do that for you, making the presumption that you want to stay on WCF, at least for now. Maybe move to something later, but in my case, I want to go ahead and stay on WCF for the moment and move to REST or something on later on. You might not want to. Core WCF might be your thing, and that's fine. It's going to walk through all the changes that we're going to make, talk about the changes to MSMQ, and roll right forward. And if I want to, I can do a pull request on both the plan. If I were to scroll down, then I could see all the code changes that it's going to make. If I wanted to set this up as a PR, I could go through, one of my devs could go through, and I actually do a really deep analysis of what Copilot has changed and make tweaks to it if I want to. That would be a recommendation I would make. Don't just take the AI's suggestions and go for it. Definitely do a little bit of massaging as well. But moving right along back to our presentation, one thing I do want to kind of talk a little bit more about is going to be the next set of steps in that app modernization journey. You'll see here that we've got a bunch of things on the screen. We're not just worried about a developer opening up an IDE, either Visual Studio or Visual Studio Code, and doing this kind of onesie, twosie, project by project. We want to enable this across the entire ecosystem. So if you're using something like Dr. Migrate or Azure Migrate or Cast in public preview, you could actually snap that into this entire modernization journey. We're working on that entire end-to-end right now. Part of that step is going to be some of our Azure migration stuff. Now, why would you want to migrate to Azure? A couple of slides here. Obviously, you want to maximize your business agility. You're going to be able to respond a lot quicker. We'll talk a little bit today about the SRE agent. You would be able to use the SRE agent in our past to help figure out what's going wrong and fix it without having to wake somebody up at 2 in the morning. You're going to be able to unlock AI with unified data. You're going to have a lot more of a secure situation when it comes to going from code to cloud. A lot of the changes that we've made across our IDEs, a lot of the changes we've made across our services recently are going to make you more secure by default, and they're going to keep you secure as you party in the cloud. And then finally, best-in-class performance. You're not going to run faster than you are in Azure, especially when it comes to .NET. We have a lot of different opportunities for you to run your .NET applications, both on hardware, on VMs, and in a variety of container and PaaS models like app service, container apps, and so on. So let's talk a little bit about how you would do that with our migrate to Azure phase. So in this phase, what I'm going to do is I'm going to reopen that project, and we're going to take a peek at what it would take to migrate that app to Azure using all those same tools that we already have handy. And then I'm going to actually show you what it would look like to kind of go step by step in that journey. Let's go ahead and close this down, and I will flip back over to my dev box once again. Thanks to my wonderful friends in the DevBox team for making this so easy to kind of get rolling. So I'm going to actually close this solution down for now. I'm going to open a different one up, open a different project up, and we're going to grab this one right here. Sorry. And just because I've already done the different phases for each iteration of the project and the branches that I've got. Sorry about that. So I'm going to right-click this again. I'm going to select Modernize. And in fact, what I'm going to do is right-click my entire solution again, select Modernize. And this time, we've already done this. We've upgraded it to .NET 10. What I'll do is I'll go ahead and click on Migrate to Azure. And I'm going to click on the next button down here. And what will happen now is that Visual Studio is going to use a lot of the existing AppCat tools that we already have. That's going to communicate with our LLM and kind of get a set of recommendations that it wants to make based on my application. Now it's going to pull up that assessment report for me here in 3, 2, 1, go. No, didn't work. Sorry. It's going to pull up the assessment here in just a second. But what it's doing is, again, it's scanning through my code, but rather than thinking about how to upgrade the code to .NET 10, it's actually looking at opportunities based on my past offerings that it knows I want to deploy to in Azure. So it's gone ahead and defaulted me to Azure Kubernetes Linux, and Windows, Windows is supported for MSMQ. So if you go down here, migrate from MSMQ to Azure Service Bus, that's marked as mandatory because I'm not going to be able to run MSMQ on AKS and Linux. However, there are some geniuses out there who figured out how to run MSMQ on AKS and Windows. So if I change that option to AKS and Windows here, you'll see that this changes to potential. It is potential. You would need to do some work, but it is indeed potential. Now, I can also change this to any of our other offerings, App Service Windows, App Service Linux, and so forth and so on. For now, I'll just click App Service Windows, and you'll see here I'm going to have to do that MSMQ to Service Bus is going to be mandatory. I would click that, and then what we would begin to see is that the migration agent would go ahead and start the process of figuring out how to change my code around so that instead of sending messages back and forth using the Windows-based MSMQ, I would be using the Azure Service Bus instead. Now, it will do that inside of a separate branch. So if I wanted to, do a PR on that branch, again, that's a recommendation, not just a what if. Always, do a review on your AI-generated code. What it's going to do now is it's actually going to inspect everything and kind of start making recommendations on how I would go up to Service Bus instead of using MSMQ. At that point, it would actually start changing all the libraries around and doing some of the other changes that I'm going to need to make. And lean in on some other things around the Azure MCP tools if I need to actually do any provisioning and fire anything up. If I wanted to, I could click continue here, but it's already gone ahead and created my migration plan. This is not my upgrade plan. This is a totally separate plan. Pardon me. My upgrade plan was how to get from .NET 4X to get to .NET 10. This is really my plan to actually migrate my app up to Azure. All right, here you'll actually see a progress, and as I go through those individual steps and I run those migration tasks, let me hit keep here so we can get rid of the green. You'll see that I've got this checklist down at the bottom, and it will actually check through each one of those to-do list items as it performs all of those migration tasks for me as we roll along. So this just kind of shows you how you as a developer, if you want to take your application forward and not only upgrade it to a later version of .NET, but then actually take it and take advantage of some of our great Azure service offerings. You have the tools directly inside of Visual Studio and Visual Studio Code to do all of that. But we want to take it a little bit further than that as soon as humanly possible. So I'm going to go just a little bit further and show some stuff that's not quite there yet, but we're getting it there as fast as possible. And that is our new GitHub Copilot app modernization, where we're going to be building autonomous workflows for modernization at scale. Now, what do all those words mean? Down at the bottom left, you'll see that we have a private preview. If you were to scan that QR code, you're going to get linked out to a form that you'll fill out. And essentially, that form will sign you up for a private preview where you would be able to try our app modernization agent. Currently, that app modernization runs very similarly to the product known as Spec Kit when it comes to actually running a series of commands to kind of generate some specs and some plans, much like the tools that you saw in the IDE run. To kind of make sure that you can edit the plan and make sure you know what's going to happen before it happens. But I do want to point out that one of the benefits of this is that we can actually run some of these commands back on the GitHub repository where your code lives. And that way you could actually set up multiple issues and start up multiple phases of your modernization journey and have them run simultaneously, hence the idea of it being at scale. Again, this is an extremely early preview. What I would recommend, and go back to the slide, Timothy Ng, and my good buddy Scott Hunter did a presentation at Ignite a couple weeks ago. So you want to look up their presentation on app modernization. Timothy does a great series of videos of this app modernization agent, and he has a lot more coming. We're working together for even more exciting demos coming soon. But look up I think it's BRK 100 or 103, I can't remember which one it is, but it's with Scott Hunter and Timothy Ng, and they talk about the private preview of the GitHub Copilot app modernization agent quite a bit. So I'm going to go ahead and dive in and do a demo that's not as good as the one that they did at Ignite, just because I'm very new to the tool, and kind of walk you through what it might look like as we get closer to done on that version of the product. I'm going to go ahead and keep and continue. Go ahead and close that down. So what I'll do now is I'll open up my command line. We won't stay in it too long. And what I'll show you is that I have the GitHub repo out over here. And I've got a couple of issues in it that I'm going to click on. And at one point, these were placeholder issues. So you'll see here the first one was a placeholder to start the assessment and get all the assessment summary stuff up into GitHub so I could start to review it. The second issue that I created was a placeholder to convert from MSMQ to Service Bus. Now what I'll do is I'll flip over here, and I've got a version of the application downloaded. This is the .NET 4.8 version from the main branch that I've got running locally. And again, we're probably going to roll this up into the Copilot CLI. How it's going to ship remains to be seen. What you see here is just built on my machine and running on my machine, so forgive me. I'm going to go to appmodkit, and we're going to just call the init method. And what that's going to do is it's going to lay down a series of files. It's going to first ask me, do I want to do this using PowerShell? Yes. Or do I want to do it using Python? For me, I'll do this using PowerShell. I'll hit PowerShell first. Do I want to do .NET? It's found that it's a .NET app. I'm going to go ahead and pick .NET because it's not a Java app. We do have support for .NET and Java in this. Hunter and Timothy's sample demo, they actually did this using Java. So I just want to show you that we do have that capability, and more languages are coming. Just we're not going to stop there. I'll go ahead and hit enter. You'll see that it's gone ahead and it's laid down a couple of files. Those files are going to be in my GitHub folder, and really what they are is going to be a series of steps that I can run. It's going to be the assessment step, the create plan step, and then the run plan step. So I'm going to go into Code Insiders now. Let's do Code Insiders right here on this folder. And I'm going to open this agent up a little bit window. And I had this all sessions up earlier, so I apologize for the all sessions window being there. I haven't figured out how to hide that window yet. But what I'll do now is I'll go over here and I'll just type appmod, and you'll see appmodkit assess. I've got create plan, and I'll do run. Now, if I were to hit assess here, I could actually tell it, I want you to assess based on the fact that I want to go to app service, or I want to go to AKS, or I want to go somewhere. I'm just going to leave it as it is. But when I did this originally, what I did was I went over to GitHub and I took this GitHub issue and I copied the link out and I pasted it. I pasted it right here so that when I ran this, it actually ran that assessment and it pumped all of the assessment stuff up into GitHub so that I could see what it was going to do before he did it. So I could actually assign that to the GitHub coding agent. Now I'm not going to run it here. I'm just going to go ahead and click this. And you can see that that assessment summary, very similar to the one that you saw show up in Visual Studio, is now all lit up right here inside of an issue in GitHub that I could actually collaborate with somebody else on, work through, and get a little bit more detailed, and make sure I'm going in the right direction. And once I am and I'm comfortable and I want to actually start my journey, I can actually do that create plan, and I could say MSMQ to service bus or whatever the next step is. And what you'll see here is it's going to go ahead and tell me what that plan looks like. So this gives me the opportunity to now assign both of these to the GitHub Copilot coding agent so that they'll be running out there instead of running right here on my machine. I'm going to close this down and I'm going to do 1 or 2 more slides for you before I hand it off to my good friends. The last thing here is going to be my calls to action slide. I want to thank you all for letting me be here. First one is going to be this provide feedback link on the left. If you're already using the tools and you want to give us feedback, we have a great survey where we're asking for feedback for you. Please be honest, please be candid, please be nice. And then the second one, we want you to try this preview out of this GitHub Copilot app modernization agent. So definitely try the preview and let us know what you think of that. And without further ado, I will get out of here, but I think you might have a question for me. So cool. One more question. So let me see.
I do have a question, Brady. Thank you very much. Now, first up, I just want to make a comment. I am 100% certain all of the app modernization play that we're doing is all for us old timers to talk about stuff like Visual InterDev and stuff like that.
Exactly.
And it's so cool, right?
That's right.
Right. So we could tell stories about, the good old days when we were using Visual InterDev and that cool logo on it. Yeah.
Exactly.
So, which that logo kind of just has morphed, right? It always was that Infinity symbol.
really is.
So, yeah, it's so cool. Visual InterDev was my favorite product.
Me too. It was great.
Yeah,
Yeah,
so.
design time controls. All
right. So let me look up a question. We did get a good question from P-Ball DUC. All right. So what if our code is on Azure DevOps, but it's all local? Can we still use the tooling to upgrade?
Yes, that's a great question. Today, you would be able to use the tooling to upgrade locally. The one that you saw me using at the end, I don't know. Today, that one does specifically target the GitHub issue API. I would imagine that we would want to bring support for Azure DevOps to that as well in the fullness of time. I don't have any timelines right now. Like I said, this is barely getting to private preview. But again, all you would need would be a GitHub account and a GitHub Copilot account, and you'd be able to use GitHub Copilot in the tooling. So yes.
Great.
Yeah.
All right. Thank you very much, Brady. Great way to start off the day. GitHub Copilot Agentic Modernization. Yeah. So it's a long word for a great tool.
Sure is.
So
Sure is.
Thank you, Brady. Really appreciate it.
Thanks a lot.
So security is actually one of the biggest deals to get up and upgrading your application. So over at .NET Conf, I did a session on this, and I upgraded a .NET framework I think it was 4.7, maybe it was 4.8, one of the 4 dots, to .NET 10. And I'll be honest, it took a little bit. We did a little slice and dice during .NET Conf to make it work, all within the 25 minutes. But it was amazing on how it just, I don't want to say it was amazing that it worked, but it did work. And it's super cool. And when it generates that plan for you, and you can actually go through and modify that plan to make it, to tailor it and tune it to get to do what you wanted to do. So it's a great way to help you modernize your apps with security, to get up to the latest and greatest like NuGet packages and all of that. So check it out. Definitely go up to the links. We'll have the links all available to you at aka.net/agentics. We'll put the links up on the bottom third. I forgot what it is offhand, but yeah, totally will have it for you. So with that said, our next session is going to be all about Azure MCP Server. Now, so MCP stands for Model Context Protocol, and it's a protocol, right? It's a way for different AI things to talk to each other really easily, so to speak. And so what Azure MCP Server does within the tooling is that it gives you like some infrastructure as code and some best practices to talk to Azure from when you're developing applications. And so as I mentioned during the introduction, as I used it during a couple weeks ago to actually upgrade and move over a Ghost, a website from Docker up into Azure Container Apps, and actually created a MySQL flexible server for it too. And honestly, I had no idea what I was doing, but I used Azure MCP along with all the code, and just was asking GitHub Copilot, how do I do this? It was in the tooling. That's where the MCP comes in. The tooling from Azure or GitHub Copilot can talk to the Azure MCP server, and it just worked, right? I got it all up and running within like an hour of half paying attention to it. So it's a great tool, and that's what we're going to talk about next, is the Azure MCP server.
Hello everyone, my name is Yoonjung Choi. I'm a product manager working on Azure MCP in Visual Studio. And today I'll be talking to you about Agentic DevOps focused on enhancing .NET web apps with Azure MCP. All right, let's get started. So for today's agenda, we're going to go over an intro. I'm going to talk to you briefly about what Azure MCP is, as well as what MCP is. And we're going to dive into our demos on building and deploying a .NET application and add a SQL and storage using IAC. And then at the end, I'm going to share you some resources. All right, let's start off by going over what Model Context Protocol, aka MCP, is. I think Matt did a great job of summarizing and explaining it right before the handoff, but let me just reiterate some of the key points. So MCP is a relatively new protocol. It's been around for just over a year still, and it was originally created by Anthropic and is now being developed in collaboration with multiple industry partners. I would say the goal of MCP is to provide a standard mechanism for AI models to access tools and resources and to extend their knowledge and capabilities to enable new and more powerful agentic applications. So let's see, MCP is actually being very widely adopted in the industry, including OpenAI, Google is using it, Amazon, Hugging Face, and many others, and Microsoft is not an exception. At Microsoft, we have built MCP support into our IDEs like Visual Studio and VS Code, and have developed multiple MCP servers to plug into these systems, such as Azure MCP Server, which we'll be talking about today. And let's go over some of the key abstractions of an MCP server. MCP server really, you can think about these three things: host, client, and server. So host, this is the LLM, AI application. Client, it serves as a connector between your host and the server. And then the server is the one that provides the context and capabilities to help extend the knowledge of your LLM and AI application. All right, moving on to the next slide. There are a few guiding principles within MCP servers. To list a few, there's like user consent and control, there's data privacy, there's tool safety, and there's also LLM sampling. But today I'm just gonna direct your attention to the user consent and control aspect of it. So users must explicitly consent to and understand all data access and operations, and users must retain control over what data is shared and what actions are taken. So, really, MCP server shouldn't be accessing, data that it shouldn't be accessing. So there's always human in the loop when we're designing MCP. All right, now let me switch gears and talk about Azure MCP Server in Visual Studio 2026. So at .NET Conference just a few weeks ago, we announced the GA release of Azure MCP Server in Visual Studio 2026, which you can use alongside GitHub Copilot to deploy and manage your Azure resources and do a bunch of different Azure operations. A cool thing about this particular release is that the Azure MCP Server is now built into the IDE, so there's no need for really any additional extra configurations. If you use the Azure MCP Server in conjunction with Agent Mode, Copilot doesn't just suggest code, but it actually becomes an active teammate that understands your Azure environment and helps you build, deploy, and manage your app end to end. With Azure MCP, you can bring in Azure resource context directly into GitHub Copilot. That means your resources, your configurations, and your environment, all of those will be accessible by the LLM, and it can give you smarter and more relevant suggestions. And you can also tap into Azure best practices. You can also generate Azure-related code, as well as infrastructure as code, which I'll be showing in my demo a little bit later on. All right, so with that, I think I can head on over to showing the first part of my demo, which is to build and deploy a .NET application. So let's get started. All right, so here I have my ASP.NET Core Razor Pages application on .NET 8, and it's called the Doggy Spa. This application is designed for managing a dog grooming business. And it handles 2 core workflows. Let's actually build a project and run it locally so I can show you these functionalities. All right, so here's my app running locally. And you can see there are a few functionalities like creating an appointment. I'm going to put my name, Yoon Jung Choi, my pet's name, Coney, and then set the appointment time to the upcoming Friday. Okay, I'm going to create an appointment. And we can see immediately there is an appointment that's been created. We can also see it in the Appointments tab. And then I can also visit the Upload Photo tab, which is not fully functional because Azure Blob Storage is not configured just yet. All right, now that we've verified that our app is actually up and running locally, what we're going to do next is use GitHub Copilot. And for the entirety of this session, I'll be using Agent Mode. I prefer using Agent Mode because it's able to, autonomously handle tasks and, perform a lot of the commands on my behalf and make direct edits to my workspace and my files. Okay, for the model, I have Claude Sonnet 4.5. And I'm just going to make sure that I have all the Azure MCP Server tools toggled on. You'll see there's 48 of them. These are actually showing up in namespace mode. So there's a lot more commands associated with Azure MCP, but we've shrunk them down to namespaces mode because LLMs sometimes have a difficult time, finding tools when there's a huge number of tools. Okay, I'm going to ask, I want to deploy my app to Azure. What are some of the best options out there? Okay, right as I send this prompt, I can see that it knows that my application is the Razor Pages application. It's using ASP.NET Core, and it's giving me a long list of Azure resources to choose from, with Azure App Service being the top choice. Copilot is also sharing its reasoning around why Azure App Service is the top choice. It's mainly because it has the native ASP.NET Core support. There's also seamless integration with Azure SQL and Storage. And it's just, I would say, a more price-effective option to get started, especially for a small production workload like mine. All right, now that I've evaluated which resource I'm going to deploy my app to, I'm going to ask Copilot to provision an app service in my current selected subscription. I'm going to specify the region. You don't really have to do this, but I just like to do it because sometimes, you can have quota issues and whatnot. So I just want to make sure Copilot gets it right the first time. Okay, we can see that a tool was invoked to list my Azure subscription, to grab my Azure subscription information. All right, it indicated that I have access to multiple subscriptions, but it also understands that my current subscription context is my personal subscription, so it defaulted to that. And it's also asking my consent for running all of these tools from the Azure MCP server. I'm just gonna simply, allow all for now. Alrighty. Okay, we're starting to provision the app service, starting off by creating a resource group. Okay, looks like that's completed. Now it's moving on to the next step, which is to create an app service plan. And it's using the B1 SKU, the basic SKU, which I said is more suitable for like a smaller production workloads. Oh, it went into an issue. Yeah, there must be a parameter that was unnecessary, so it looks like it removed the parameter and ran it again. The nice thing about Copilot is it's able to iterate on its mistakes, and it's very persistent when it comes to getting its tasks done. I would say it's probably way more persistent than I am. So you can see it keeps retrying until it gets it right. All right, looks like the app service was provisioned, and there's been a second attempt to create a web app. All right, there's some activity going on in the terminal indicating that, okay, the deployment was successful. And at the end of, there's a little bit of error, I would say, but I think based on the terminal output, I'm pretty sure the resources have been provisioned. So I'm just gonna ask Copilot. Okay, now Copilot is confirming that indeed my resources were successfully provisioned. It must be a transient issue in the chat that was not showing the chat responses, but the resources have been successfully deployed. All right, and now Copilot is giving me a nice summary of all the things that it did. Now that I have an app service up and running, I'm going to create a publish profile and publish my application to the newly provisioned resource. Okay, we can see that Copilot is querying Azure Resource Graph to gather some information about my resource. All right, it looks like it finally went through. Okay, based on the terminal output, I can see all the necessary details have been fetched. And the necessary information from my app service plans also been fetched. Now, the tool for creating Azure Website Publish Profile was run, and I can see that the Publish Profile has been created. I'm just going to move that out of the way. And now Copilot is running the Publish tool to actually publish the profile. Oh, looks like it ran into an issue. Copilot is validating the build error. The build is successful. This tells me that this is more likely like an initialization issue, and it usually resolves itself if you do a retry. Okay, Copilot is trying publishing again using Azure CLI. All right, and we're getting indications that the application has been built successfully, and it's now being deployed using zip deploy. All right. Okay, now Copilot is validating if the deployment is working. Yep, and then the deployment have succeeded. Great. And like before, Copilot also generates a nice summary of all the actions it took. All right, we're going to get a application URL, so which means our app should be up and running on cloud now. So we're going to copy and paste that into a browser tab. And we can see there our app is up and running. And it's now hosted on the app service that we just provisioned using Azure MCP and GitHub Copilot. And let's check the functionalities. And I'm able to create my appointment. Awesome. Now let's move on to the second part of the demo. Now that we have our application up and running, we'd like to add SQL and storage to it. But this time we're going to use infrastructure as code. This is going to be an interesting experience because I myself actually don't have any previous knowledge on infrastructure as code. So let's see what Copilot and Azure MCP can do for us. So I'm going to simply prompt Copilot to generate a bicep template for adding Azure SQL and storage. And I'm going to say do not generate any other artifacts like deployment scripts because I know sometimes Copilot likes to get wild with creating these scripts, so I just want to avoid that. And I'm also going to nudge Copilot to use Azure best practices. We can see an ask to run Azure MCP servers, Azure best practices. I'm going to consent. Also, we're calling into Microsoft Doc Search, which actually is integrated into Azure MCP as well. All right, so Copilot is calling all of these tools to get more up-to-date information around bicep generation and Azure SQL database best practices. And I can see that the bicep files are being generated as we speak. All right. Okay, now we're getting a nice summary, again, indicating that our bicep files have been successfully created. They should be in the infra folder, and they are also following some of the security best practices. Okay, let's now validate if these files are actually there. So we're going to go to the Solution Explorer, change to the folder view, expand on the folder, and yeah, under infra, we have several bicep files, the main bicep and the bicep parameters, which is great. Yeah, I did not have to know a single thing about bicep to be able to author these bicep templates. Now, one thing I noticed though is that when Copilot was generating these bicep, it wasn't calling one of the Azure MCP tools for bicep schema. Sometimes that happens, so I nudged it to actually call into it, and then it was able to run additional validations on the bicep templates and made some additional changes as well to update the storage account API version to the latest one, and basically what you're seeing on the screen right here. All right, now that we have our bicep templates, we're going to deploy using the instructions that's shared in one of the summaries. All right, so Copilot is first verifying that if I have my Azure CLI installed, because that's what we're going to be using for the deployment. All right, it's checking whether I'm logged in, and I am logged in. It's grabbing my Entra ID, Object ID, and the SQL Server admin configuration, filling out all the necessary details. All right, now the parameters file are being updated with some of the real values, like the actual values. We were able to just grab. All right, looks like we're hitting some sort of a warning because of the storage account name. Potentially it's too long. So there are some naming conventions changes that we're making. After that, the bicep template is being validated again. Okay, now we're moving on to creating the resource group. Okay, now we're doing an analysis to preview the changes before deploying. Yeah, this step is going to take a little while. Okay, it looks like we're hitting a policy error, but we don't need to worry. Copilot is very persistent, and it's going to iterate on the error. Okay, now we're doing one more what if validation. Looks like there's an error again. Okay, this one is to enable the Entra-only authentication at the server level. So some additional changes are being made to my bicep. One more check to validate the what if scenarios. All right, looks like it finally went through. Okay, so these are all the resources that will be provisioned. Okay, so we're hitting an issue because the East US region is actually restricted for my subscription. So what's going to happen next is the Copilot automatically chose a different region to deploy these resources to. So we're going to deploy to the West US region. We'll need to create another resource group and clean up the old ones. All right, so there's a slight, like a naming conflict, so we're trying out a different name. All right, we're now deploying the new resource group. And right now I'm like showing you this demo, but you can actually have this just running kind of in the background as you're working on something else. So really, the autonomous nature of agent mode helps you, it helps improve your productivity because you can just, have this running and sort of just pay attention to it. All right. Okay. Looks like the deployment was successful at last. Okay, it's showing the new resource group that it just provisioned in West US 2, and then also listing out all the resources that were captured in our bicep file as deployed. Great. No, now after this step, we're running a little bit out of time. So after this step, what I ended up doing was I just prompted the Copilot to update the app settings with the newly provisioned resources and also granted the app access to the SQL database. And we were able to get the app up and running. As you see in the screenshot, the connectivity status have been updated to be both green, and I was able to successfully create appointments. All the functionalities were working, and even the upload the pet photo page was working as expected. So with that, I just want to end by just nudging all of you to try out Azure MCP. It's really a must-have for Azure developers and also those who want to learn about Azure. It significantly reduces the learning curve about Azure development. It helps boost your productivity by giving LLM Azure context, and it helps you tap into some of the Azure best practices so you can build something that is production ready. So here are some of the resources I want to share with you today. The Get Started link will take you to how to get started on VS 2026 with Azure MCP. The blog link will take you to our recent GA announcement, and the repo link will take you to the Azure MCP All Up repo, which will have multiple instructions on how to get Azure MCP set up in different IDEs. So with that, that's the end of my session. Thank you so much for watching.
Wonderful. I really, really like the Azure MCP server, and the chat likes it too. We have a lot of questions going there, so I will throw some to you in just a second, but I just want to mention that we'll take all the resources that you just had and we'll throw them into this overall list that we're curating today from all the sessions so you can check them out. And it's coming up, the URL for it's coming up at the bottom, and I messed it up last time, but it's aka.ms/agentic-mod/.net. But you'll see it. It's right there. All right, cool. So yeah, Azure MCP, it's kind of like your vibe coding, but with all of Azure added. And so one question that did come up in the chat that I just wanted to address real quick is, are there going to be any sessions on AI safety? And as you can imagine, that's going to be a big deal. We're creating Azure resources out there and messing around with them. And not today. But that's a great idea. And that's something I'm going to have my team work on, because that's something we definitely have to address. All right, so now on to the questions. So the first question that we got was, how does Copilot here decide on which of the tooling to call, which tools to call? How does that work?
Yeah, so Copilot looks through the tool descriptions that are provided by the Azure MCP, which in our case, I was showing you earlier, we had the list of tools. There were about like 48 of them. Those tools were showing up in namespace mode. So what they really are like tool groups consisting of multiple tools. So in that case, what Copilot will do is based on the namespace mode description, they're going to call the most suitable namespace, and then MCP will be making a sampling request to the LLM to suggest the most suitable tools that it has among that tool group. So that's kind of how the process works. It varies from model to model. Sometimes tool invocation is better on one model, and sometimes it's not as good on the other model. So it really takes practice, and if you'd like to try it out for yourself, I think that's the best way to go about it.
Cool. And so another question is, and this actually is a really good one. So we know that the Azure MCP server, like you showed the demo right at the beginning, where it was like, all right, where do I want to deploy this? And it said app service. And you could be going to Azure Container Apps. So what constitutes really the best practices? And then is it possible to fine tune those best practices as well?
Yeah. So let me address your first part of the question first. So when it comes to deciding, which resource to use for your deployment, I guess it's really up to your requirements and your needs. But in our demo, when we were actually using an ASP.NET Core app, and it already had some connections to SQL and storage. So for it, Copilot deemed it Azure App Service was the best option because it comes with a lot of the innate support for ASP.NET Core. And then the second part, actually, there is a tool called Azure MCP, within Azure MCP called Azure Best Practices, which lets you kind of tap into Azure Best Practices like, okay, you should be using managed identity for authentication and, all sorts of, those like nitty-gritty details to make a production-ready application. So I advise you to check that out as well.
Cool. And then the very final question, and something that you might not be so prepared to ask, but it's like the million-dollar question, is how many tokens is this using generally, and especially like on the retries? Do you have any idea? And I know it's not the most fair question, but how many tokens generally have you been seeing this go through?
Yeah, I actually don't have the answer top of my head. And also, one of the benefits, and also I guess a downside in this case is that, as someone who's working on the product, I sometimes kind of overlook the cost aspect of it. But so I don't have the answer for that right now, but that's something that I should be considering for my other demos.
Yeah. And thank you. And that's totally something, the cost aspect that we want to hear feedback on, and we're always looking how to improve things. And so this goes across everything, not just the Azure MCP server, but Copilot as a whole. We totally want to hear what you're experiencing and where we can make things better. Yeah, so feel free to send us that feedback all the time about everything, anything, whatever you want. We want to hear it. All right, so thank you very much, Azure MCP server. I'm going to actually ask all our presenters to also check out the chat. So they'll go through and answer any of the questions that we didn't get to live here. So put the questions in. Our speakers will go through and answer them afterwards. All right, so next up on the agenda, we're going to talk about more agentic development tooling, but this time a little bit over on the SRE side of things and the Azure SRE Agent. Now this is something personally I haven't really ever gotten into in my career so much, and that's really, we're using something, we've got our stuff up on Azure right now, but we want to know, hey, is this working? What happened to it? Is it up? Is it down? What's going on? And that's what we're going to hear about next with Shamir. So Shamir, take it away.
Hello, everyone. Thank you for joining us. My name is Shamir Abdulaziz, and I'm a lead PM on the Azure SRE Agent project. And today, we are going to have a jam-packed session that will help you see how the Azure SRE Agent is going to help resolve issues even before your users experience it. So let's get started. Like I said, it's going to be a demo-heavy session. I have a couple of slides to explain the concept. I'm going to talk you through what the SRE Agent is and how we are going to use it to resolve an issue before you spot it. I think we've all been there, right? You've deployed a code to staging, tested it pretty well, you uncovered no issues, went back home, you're fast asleep, and suddenly in the middle of the night, you're woken up because there's a bad deployment. Hopefully, with the Azure SRE Agent, it's going to be a thing of the past. And let's see how. The Azure SRE Agent is an AI-powered Azure service. It's meant for diagnosing and resolving production issues. We do this by real-time incident response, and you can use the Azure SRE Agent in 3 different ways. You can interact with it, much like a Copilot, where you can query your resources, configure it, investigate it, and even deploy it. You can then also use it in the reactive mode, where you can handle alerts from Azure Monitor or incidents from PagerDuty or ServiceNow. And you have a custom runbook defined through the Agent Builder experience, where you can respond to those incidents in real time. And finally, proactively, we provide you best practice recommendations, security vulnerability reports. You can configure the agent to do anomaly detection proactively or send you other reports that are useful for your management. And finally, the most important part of the SRE agent is you can truly make it yours. So we provide you the capability to bring your own tools. We allow you to build the custom prompts and connect it to the tools and data sources that is important for you, so that the SRE agent understands the context and troubleshoots the issues. With that, let's jump into our first demo. In this demo, what I'm going to do is show you how the SRE agent is deployed and how you can use it. All right, first up, I'm going to show you how to deploy the Azure SRE Agent resource. It's like any other Azure portal resource. You go to the Azure portal, you search for the resource, look for Azure SRE Agent, and then go ahead and click on the Create button. Now, once you click on the Create button, you fill in the standard boilerplate values. You provide a subscription, you provide the resource group name, you provide the name for the agent. So I'm just going to name it .NET. Select the region. I'll select East US 2 for now, and then you can select the resource groups that you're interested in. I'm going to select the resource group that I set up for this demo, hit Save, and then hit on Next. So you can see now the agent has access to this resource group. I'm going to hit Next. And now you can configure the agent's permission level. You can configure it to be read-only, in which the agent then can only read and inquire about your resources. And for any action you need to take beyond that, the agent is going to prompt you for your approval, and then the agent is going to use your credentials to take care of that action. And then you have the privilege mode. When you select the privilege mode, the agent can take some write actions too. What actions it takes is based on all the resources we have identified in your resource group. And you can see all the permissions the SRE agent is assigning itself via its managed identity to access these resources. So I'm not going to hit Create here. I already have a resource created, so I'll show you what happens when we deploy an SRE agent. Once you deploy the SRE agent, what you see is the welcome thread. In here, you'll see what the SRE agent can do for you. It starts with telling you the resource group it understands, and then all the resources it found in that resource group. And then it gives you some starter templates on how you can interact with the SRE agent. I'll get to the chats in a bit, but before that, I want to show you another cool thing that the SRE agent does. So remember, when we deployed the SRE agent, we selected a resource group. Now, in that resource group, I had a bunch of resources. The Azure SRE agent automatically identifies these resources. So in here, you can see there's a web app. It has a staging slot, and these 2 web apps are hosted in the app service plan with so-and-so name. And then it also has certain Azure alerts configured for it to send its instrumentation and telemetry. The only other thing that I did over here is I connected the GitHub source code repo by clicking on the GitHub configuration over here and provided the GitHub source code. Why this is useful is now the SRE agent has the context of the web app's source code, so it can do a lot more things. And then finally, in this demo, what I want to show you is how you can interact with the SRE agent. Remember at the start, I said you can interact with the agent. So this is that Copilot experience. You could ask anything about your resources in here, and it's going to try and answer those. So in here, I've asked, list all the web app and its health. And so you can see its thought process and the to-do plan it created. It said that I'm going to do an inventory of all the web apps in the subscription, gather the health indicators, and then provide a summary. And you can see that it did that here. So it found out all the web apps, found out the state, and saying the availability is normal. So that's pretty cool. So that's the first demo. Now let me switch back to my slides. And before I go into my second demo, what I want to show you is how I've set up the SRE agent for it to do what I talked about. That is, being able to identify an issue before it happens and fix it before an incident is created. So for that, let me just bring in my laser pointer. And on the left-hand side, what you have here is a standard app service, right? You have a .NET app hosted on Azure App Services. It sends its telemetry into App Insights, and we have some Azure Monitor configuration to fire alerts. In the middle is where the crux of the demo lies. We have the Azure SRE Agent. It's powered by this agent runtime. This runtime is the main orchestrator for everything SRE Agent. It connects all the tools, the data sources, the knowledge store, and can be triggered at will. How this works is the agent runtime has access to tools. So you can see in the lower right corner, we have built-in tools. Think of things like AZCLI, kubectl, ARM APIs, all of that. And so with those tools, you can inquire into your resources, configure, deploy, do many things with those built-in tools. We also have built-in tools for being able to query application insights or Custo clusters or Cosmos DBs. The runtime also has support for runtime memory, and so you can store knowledge into the knowledge store. And you can also bring in your own knowledge resources, whether it's in Wiki or somewhere else. You can get that knowledge into the agent runtime's context. You could also bring in your own tools. So we have support for MCP. Now, MCP allows you to add your own custom MCP server or a third-party MCP server. And all the tools exposed by the MCP server is going to show up as tools in the agent runtime. If you don't want to set up your MCP server, you could create your own tool within the SRE agent platform using the Python interpreter. We will help you write the tool you like, and then the agent runtime can call that tool at will. On the left-hand side of the runtime is the way you can trigger the SRE agent runtime. So we have an incident trigger that can be triggered based on an alert fired by Azure Monitor or by an incident that occurred in PagerDuty or ServiceNow. You can also trigger the SRE agent at will on predefined intervals with a scheduled task. So once the agent is triggered, then you can make it respond to those alerts or triggers using your own custom runbook. And this is how you truly make the SRE agent yours. So we have the sub-agent concept on the upper right corner here. And for the demo, I have two sub-agents created, and I'll explain what those do in a bit. But the sub-agent is the way where you give the SRE agent a custom prompt and the list of tools that you want it to use, and then connect to the different data sources and systems for you to achieve your end goal. Now for this demo, what I've done is I have a scheduled task configured in SRE agent that queries the application insights for some telemetry. The telemetry that I'm pumping from the .NET service is basically standard stuff like response time, CPU usage, memory usage. So this scheduled task every 15 minutes is going to go and query the application insights and then find out the baseline for the average response time in the last 15 minutes and then store it in the knowledge store so that the agent has access to that runtime memory. So that's the first part. And then what happens every time I deploy something to prod, a swap alert gets triggered in Azure Monitor, and that alert will trigger an incident trigger in SRE agent, and then the SRE agent will use the health check sub-agent to respond to that trigger. In the health check sub-agent, I've asked it to do a bunch of things. Basically, look if the current response time is beyond the baseline, and if so, then go ahead and do a swap operation, and also go and search in GitHub source code, find out if there's any recommendations it can make on why the response time went up, and create a GitHub issue. And then finally, it'll post all of these details of the deployment, the summary of the deployment, into the Teams channel that we have set up. And then I also have another agent, which is a reporter agent, and its job is basically to look at all the deployment posts in Teams for the last 24 hours and then send an email to your management. So let's see how all of this gets in action. So let me jump into the demo. All right, the first thing I want to show you is the schedule task. It's configured to run every 15 minutes. You can see it has run a few times. Basically, it does pretty simple things. You can see the to-do plan here. It's run an application insights KQL query for the last 15 minutes and found out the baseline and stored that baseline in the knowledge base. So you can see that it's run that query here, and then it's gone ahead and found out the baseline response time, which is 116 milliseconds. And so it goes ahead and stores it in the knowledge store. So that's out of the way. The next thing I want to show you is the alert that I've configured on Azure Monitor. It's a swap alert, pretty standard stuff. It fires a Sev4 alert when a swap operation happens on the app. All right, great. Now, so we have a scheduled task getting the baseline. We have an Azure Monitor alert firing when a swap operation happens. So how does the SRE agent use that? So the first thing you've got to do is configure the incident management platform for the SRE agent. By default, it's connected to Azure Monitor, so no extra additional steps are needed here. It understands all the alerts fired at a subscription level. If you wish, you could also change it to PagerDuty or ServiceNow, and most service providers will be added down the line. So you can handle any instance from those systems. All right, we have set up that. We have set up the alert. So now let's see how the SRE agent can handle that alert. So what you do here after you set up the Azure Monitor integration is you create a new incident trigger, and you do that by clicking on incident trigger here. And what you can see is a pretty straightforward thing. I have a name for the trigger, and it is going to use the deployment health check sub-agent, which we'll see in a bit, to respond to that alert. And it's configured to respond to any Sev4 alerts that have the word swap in it. So that's pretty much how you'd set the trigger. All right, great. Now let me show you some of the already handled alerts by the SRE agent. So the first one is a pretty good deployment. So what's happened here is I pushed something to prod, and a swap operation happened, and that fired an alert. SRE agent got the alert, it handled the alert, and now what you're going to see is what it did to handle the alert. So in here, what you can see is it's doing a bunch of things. And I'm going to click on the to-do plan here, and you can see that it's querying the current response time from application insights. It's going ahead and looking up the knowledge resource to find out what was the baseline time added by the scheduled task. It compares the response time, see if it's deviating beyond what I've configured it to, in this case being 20%. And if it's beyond 20%, go ahead and do a swap and file a GitHub issue. And then finally, post an update to Teams. And you can see over here, it's done all of that. It's found the baseline, it's looked up memory, and then it's come up with a summary that the current response time is 75 milliseconds, which is way under the original base time, 116 seconds. So no swap or GitHub issue was required. It was a healthy deployment. Awesome. Now let me show you the next alert that it handled. And in this, it was a bad deployment. So it does all of those things that it did earlier. So go up and look at the current response time, and then it determined that, oh, okay, swap executed at this time, and there was a 20%, a regression which was about 20%. The current average response time is 212 milliseconds, which is above the baseline by way too much. So it's going to go ahead and create a GitHub issue and post these updates on Teams. Let's see what the GitHub issue looks like. So the GitHub issue is basically summarizing all of that it found in that alert, all the metrics it found. It's going to add all of that information and then do a semantic search in the GitHub source code and then find out what happened. And see if there's anything in the source code that it can improve. So it goes ahead and adds a GitHub issue with all the recommendations it can come up with. And what's really cool is it automatically assigns it to GitHub Copilot. Now, you can see the GitHub Copilot has already started working on it. Let's take a look at how the GitHub Copilot helped us here. So you can see that it's made some code changes for which you can come back and review. So what did we just do here? So a bad deployment happened and something the response times became slow. The SRE agent acted upon it, identified there was an issue, swapped the deployment to mitigate the issue immediately, researched the code base, understood what areas can be improved to improve the response time, and created the GitHub issue, all without waking you up. You can come back to office the next day and then review this GitHub issue and see if the code is good, make changes if you wish, and check in this code and start a new deployment to ensure that the response time still stays in the healthy range. All right, so it's created the GitHub issue. GitHub Copilot has gone ahead and created the PR for you. You just need to review it. Now, for tracking purposes, what we're going to do is show all the posts that the agent made in the Teams channel. So here you can see, much like how you would collaborate in the real world, you would go ahead and post these updates about deployments and issues that happen on a Teams channel so that your colleagues can find out what's going on. So that's what the agent did here. It's providing all the details over here about the deployment, whether it was healthy or not. So there are a bunch of healthy deployments. You can see it as it's saying healthy. It also provides you the application insight query that it ran with the accurate timestamps, so you could go back and run these queries to see if the agent did the right thing or not, right? So that's a healthy deployment. Let me go and find an unhealthy deployment. I should see something down somewhere. Let's see, I think, yeah, this one was an unhealthy deployment. So in this case, you see the time after deployment was 212 milliseconds, way above our original baseline. And so it's going to say, I'm going to go ahead and do a swap, and it was an unhealthy deployment. Awesome. Finally, I'm going to show you the thread, the reporter thread, which is going to go ahead and send that email after analyzing all the posts on the Teams channel. So what you can see over here is the agent goes ahead and looks at all the posts from the Teams channel for the last 24 hours, extract the details, build an executive summary, and then compose a rich HTML email and send it to the email address I mentioned there. Let's see what the email looks like. The email over here is this. So it says that there were a total of 9 deployments in the last 24 hours. 6 of them were healthy, 3 of them had rollbacks, and it gives you a table with all the details right in there. So your management can understand what exactly happened, what issues were there, and how we mitigated those issues. All right, this is all cool. So I showed you how the SRE agent can do this for you, but how do you do this? So the next section of my demo is to show you how you can build these things. So the first thing we used was the schedule task. The schedule task is pretty simple. You click on create task here. I'll show you what I've created here. It's basically, again, natural language. All of this is natural language. So you just type in instructions and the agent can make sense of it. Since this is kind of cluttered, I'm going to open it in Visual Studio Code, so it's better to read. So now you can see that the first step I have asked the schedule task to do is run this Custo query against the application insights to find the average response time, and then extract those values and update to the knowledge store. So that's pretty much it. You just provide the schedule task a prompt, and it should be able to do this for you. The next thing I want to show you is the sub-agent, the main sub-agent, which is the deployment health check sub-agent that gets triggered on a swap operation and then has access to all these tools to carry out the instructions you provided. How do you provide those instructions? You do it in this template over here. You just provide the instructions over here. It's going to follow those instructions and connect to the tools and do what you want. Again, because this is pretty small screen, I'm going to open it in VS Code and show you what it looks like. So I've given it a goal. I've told the sub-agent, your goal is to look at if the current response time is higher than the baseline. If so, swap the operation and then create a GitHub issue if needed and post a Teams update. I've given it information about the web app I'm interested in and the application insights that you need to query. And then I've given it tasks. So I've first said you connect it to application insights with the resource ID I've given above. Run this Kusto query, go ahead and update, look the knowledge store and find the information for the baseline. Pass those baselines, do a comparison, see if it is higher or lower than the existing baseline, and based on that, make a decision to swap or not. And then finally create a GitHub issue and post to Teams. And I've also given it a format for it to follow. So I've told that this is the format I want it to follow. So every time the agent posts something on the Teams channel, it's going to follow this format. So that's how the sub-agent works. Now, let me show you the reporter sub-agent. The reporter sub-agent is pretty straightforward, pretty simple, not a lot of things going on here. All it does is it gets the messages from the Teams channel and then goes ahead and sends an email. You can look at the prompt over here. It's basically telling that go and look up all the messages in the Teams post and then create a rich HTML mail. And I'll just show you what I've asked it to write in the email. The email is like an executive summary of how many deployments happened, how many healthy deployments, how many rollbacks were needed. And then make it look attractive with a tiles kind of format, and then use a table to provide this information as a summary. And you saw how the email turned out, right? So pretty simple. You just have to write it in plain English. It'll understand your commands and send out an email with the format you prescribed. All right. All this is cool. I threw a lot of it to you, but now how do you actually iterate with this, right? And we got you covered with that. You don't have to figure out how to write all these prompts. What you do is you just come into the playground, and this is available in the Builder experience, right? What you just do is you just provide a goal. And you can say the goal is, I want you to look at application insights, see if the CPU usage is high. If it is so, go ahead and scale it up. And you just do that, and then you click on Improve with AI, and it's going to create that entire plan I showed you in VS Code. It's going to create that YAML file with all the instructions step by step and suggest the tools that you want to connect to get this sub-agent working. And what's even cooler is that you can go on to the Test and Refine Your Agent tab and go ahead and ask it to run that agent for you interactively. So I can say, run a health check, and it's going to start the entire process that I just demonstrated, right? So it's going to go ahead and do that and come back with the results. What's cool with this is you can see how the agent is going to respond without making actual changes to the system. And then once it gets to the stage where you like it, you can connect it to the incident trigger that I showed you earlier, and then allow the sub-agent to use this response plan to trigger that for you. And that's what I had for this section of the demo. And let me switch back to my slides. So what did we see here? What we saw here is how you can use the Azure SRE Agent to coordinate a response to an alert that was fired by Azure Monitor, and then make sure it responds to it using the tools and the plan that you provided, right? And it's pretty straightforward and simple because all are AI powered, and you have an agent builder experience to help you do that. With that, I'll leave you with some resources. I have a YouTube link over here. Use the YouTube link to catch us on all the great demos that we are posting. tool links to understand the product better. And you can also reach out to the SRE Agent team. I provided you the email address, and you can connect with me on LinkedIn. We are looking to hear feedback, and we are iterating on this product pretty fast. We are currently in preview, and we want to go GA pretty soon. So more feedback and more experience we can hear from you, the better it'll be. And with that, that's all I had for today. Thank you.
All right. Thank you so much, Shamir. That was really great. So one quick point, we'll take all the links and put them out into one big list. And I've been told over and over again I'm getting the URL wrong. It's at the bottom, right? aka.ms/agentic-mod. The good thing, though, is all the URLs I've been saying all resolve to the same spot, right? I created a whole bunch, and we all push them to the same spot. But use the one at the bottom. All right. So Shamir, we have one question here that there's actually a whole bunch of questions on the YouTube chat, so please go check them out, Shamir, and so you can answer them. But one that really caught my eye is that can GitHub Copilot or GitHub CodeQL security alerts be fixed unattended with this?
Right, so it's how you prompt, and great question. So the question is like, how do you make the agent do what you want? And the agent builder experience is how you expose that. The agent has built-in tools. If the built-in tools don't help, then you have MCP. You can bring in your MCP or write your own tools, right? And you write those tools, you provide the agent instructions, you provide where it has to go and look for those data sources to make a judgment, what tools it needs to go and fix that out, and you just orchestrate the entire thing. So pretty much what I'm trying to say is, if there's a scenario, if there's a tool, there's a prompt, you connect all of it together and get it to do that action, and it should be able to resolve that for you.
Great. Well, thank you very much. Really appreciate it. So the Azure SRE Agent, keep everything up and running. Super, super cool. All right. So now in our next session coming up, we're going to talk about modernization without writing a line of code. And that's all the managed instance of Azure App Service. So this is a brand new feature of Azure App Service that was just put out in public preview at Ignite. So super fresh, super hot, and we can't wait to talk about it. Like I said, just take your code, pop it out on App Service, and away you go. Super, super easy. So I'm going to toss it over to, oh, hold on. I am not going to toss it over quite yet because, I'm going to talk a little bit about what we can do at the managed instance of Azure App Service. And so what it really is, so if you have an app, let's say it is just like when Brady showed it at the beginning and really complex, and you don't have the time to upgrade it and go through the whole testing process of after you ran it through GitHub Copilot App Modernization Assistant, and you need to get it up super quickly. That's where Azure App Service Managed Instance comes in. So you can just kind of almost do a lift and shift and get things up running on App Service. Don't need the VM or anything like that, and you can just keep on going. So yeah, super cool. And another great thing about it is that you can bring your older applications, I hate saying older, but more your legacy type applications, and get it up and running up on App Service too. So takes care of that lengthy migration, bring it up right away. So yeah, I'm really kind of cool. I'm jazzed about this one and how we can get it up and running so quickly. So yeah, lift and shift, re-platform those hard to modernize apps. And you have like, another thing I wanted to bring up, like if you have these big modernization projects and you want to do incremental modernization to it. So a lot of times we're going to have things where you might have, like think about you're doing cloud native, right? But you're on-prem doing this kind of cloud native on-prem. You have a lot of different microservices running on-prem, right? And you only want to bring certain ones up at a time, or you're going to break your monolith up one at a time, right? And you're just kind of bringing them up to App Service. So this really is kind of doing your lift and shift over to App Service just a little bit at a time, and so you can kind of break it down, make it easier to handle, and really only bringing the parts up that you need there. So it's kind of, you kind of sit back and reevaluate what you need to do there. So cool. So again, I want to point out that we are going over to aka azure.ms/agenticmod to get all the information that you want to have about this. And so a little bit later this afternoon or this morning over here in Redmond time, we're going to be talking about building agents as well. So you found out all about how to modernize and get your stuff up on Azure, and even a little bit about how to monitor it. Well, we're going to talk about actually building the agents themselves with the new Microsoft Agent Framework for .NET, which is super cool, and even using durable Azure functions with it as well. So that's coming up, but like I said, first we're going to be talking about managed instance on app service. So let's see, another couple of the scenarios about it is like, yeah, if you want to modernize legacy .NET apps, with the hard-coded, the hard-coded file paths or COM dependencies, or you need to have registry access. So think about all these applications that we built, right? Built back in the day when we knew we were running on Windows, and we knew that we just didn't know that we were going to the cloud one day, right? And so that's what a managed instance helps you accomplish, to take all of those and to bring you to the cloud in a relative easy way. So really excited about that. And like I said, brand new, up during Ignite. It's in public preview, so we can take it away at any time. So let's hand it over to Andrew and Gaurav to tell us all about it.
Thanks, Matt. Hi, everyone. We're here today to talk to you about no-code modernization for ASP.NET with managed instance on Azure App Service. I'm joined by Gaurav today, my colleague, and we'll be taking you through this exciting new capability. Today, we're going to discuss a lot of the modernization challenges and why we built this new offering for App Service and how we address those challenges. And then we're also going to go through a detailed demo and then wrap up with how you can extend existing apps with AI. And we'll share some next steps, some resources for you to go and get started with managed instance on Azure App Service. So when we started to research this feature and talk to our customers, we really wanted to address modernization challenges that you all feel on a day-to-day basis. So they can be everything from you've got an application that has key dependencies. So you may need to install a library into the GAC. It's an older application, and you need to install, say, some DLLs, some resources into the GAC. You may need to install components such as Crystal Reports or some other libraries, some control libraries from back in the day from our partners, or maybe something that you've built in-house. Maybe it's an ISAPI filter or an ISAPI DLL, a variety of different things, Windows services, for example. Maybe your configuration's not so modern and you rely heavily on, say, the Windows registry. Today in App Service, if you deploy a code app, we don't allow you to install anything, but equally we don't allow you to read and write from the registry to any place that you wish to go to. So if that's been an impediment to stop your modernization, then that's something we want to address. Local and network file I/O. So maybe you need to write to a drive letter. Maybe you need to write to a particular drive letter and share, and you can't make application code changes because you just don't have the source code anymore. So we're targeting scenarios where you do have a source code, but also where you don't. Maybe you've just been handed off some DLLs. Maybe you've got a critical application that's running on the proverbial PC under somebody's desk, and it's absolutely critical to your business, but you need to move it onto more resilient and scalable hosting. Reduced access. So one of the things that we've heard from customers over the years is, well, I can't get direct to the machines. I can't do the things that I'm used to doing. I can't use Event Viewer, or I can't literally get onto the box to go and investigate and tinker with things and go and do some troubleshooting. And this is where we come into changes in tooling. Changes in tooling can be an impediment to modernization, and they can slow you down because it's the proverbial, you've moved my cheese, I'm not familiar where I am, and I just really don't feel comfortable. So how do we solve that problem? In-process session state is often a significant challenge to scaling. So how can we help you with moving applications that do maintain session locally? And then one of the bigger challenges, which is outside of the technical, is migration takes too long. So you go and do an assessment of your source code or your application estate, and you're hit with, well, application A is going to take 6 months worth of code changes and testing and rollout before we can actually move that to the cloud. And then I've got another 6 or 7. So then you compound and extrapolate that time, and it just makes it go longer and longer and longer. And so the return on your investment doesn't come quickly because you're spending all of this time making code changes before you can actually do any form of modernization and migration. So how do we at the App Service team address these challenges? So as Matt mentioned, at Ignite a couple of weeks ago, we announced the public preview of Managed Instance on Azure App Service. With this offering, we're hoping to enable you to be able to accelerate that move to platform as a service. So you can skip having to go to pure VMs. You can come straight to a managed platform that is App Service. You can preserve your Windows dependencies, so you can bring them along with you. You can install your components to the GAC. You can install your libraries, your third-party dependencies. And alongside all of this, you can unlock scale, security, and Azure AI. So scale, you've got a global platform. You can go out in a single app service plan to 30 instances, move to multiple regions. You've got a secure platform. App Service and Azure is ratified under various compliance standards and security standards. And additionally, you can expand your existing applications to take advantage of Azure AI. On top of that, we've made this offering available on Premium v4. Premium v4 is the latest and greatest hardware SKU that we have with inside App Service, and it offers some really attractive pricing plans, including you can tie those in with reserved instance pricing and savings plans so that you can get real return on that investment. Capabilities. You can bring your dependencies and with your application through an install script. So we have an installation or /configuration script that is written in PowerShell. You bundle your dependencies up in a zip file with an install.ps1. That script is run on each instance as we deploy your applications. And then as you scale out, the same thing happens again. You can use storage mounts for local and remote files. So as Gaurav's going to show you shortly, you can use the local disk for temporary storage. You can use Azure Files, or you can use a UNC share with inside your network. We have support for you to be able to read and write from the registry, and the settings that you actually apply can be backed by key vault secrets. So we've got security in mind all the way through. You can use familiar tools for troubleshooting. For the first time ever in App Service, we're going to allow you to RDP to the instances directly using Azure Bastion so that we've got security all the way through. And again, like I mentioned previously, you can take advantage of the platform scale and the maintenance that we do as a PaaS. We patch the underlying VMs, we rotate those, we maintain them. You got the scale inbuilt with each one of our regions. And then as we're going to show you as well, you can modernize and expand your application's value with artificial intelligence. I'm going to hand over to Gaurav now, who'll give us a comprehensive demo of Managed Instance on Azure App Service.
Thanks, Andrew. In order to start creating an app service plan for Managed Instance on App Service, we basically start by getting to the Azure Marketplace and searching for a new template. So just start typing Managed Instance. And here you go. You can now see web app for Managed Instance. Now, once I click this, I can actually click on Create. And you will see that most of the experience that you are seeing on screen is pretty familiar. So I'll provide a resource group name. I'll give this a demo name. Now, when it comes to runtime, you'll see a slightly reduced list of runtimes. The reason here is these are the runtimes which are by default installed on the underlying child VM. That's where your plan is actually getting provisioned. But that doesn't mean that you are only restricted to these runtimes. You can obviously get runtimes like, let's say, Java, or if you are looking at Python, and I'll show you how you can do that. So I'll go ahead and select 4.8. Now, again, when it comes to the regions, since this feature is currently in preview, it's only available in these 4 regions, but we will be adding, and I should say we are adding more regions as we keep on propagating the preview capability. So maybe I'll just select West Central US. Now, as Andrew mentioned, it's extremely important to note that this new feature is available only and exclusively on PV4. So it's exclusively available on PV4 and PMV4. Now, if you want, you can also enable zone redundancy. Let me go ahead and click on next. Now, this is where the new experience or the new way of creating and deploying your web app starts. Now, I need to select a storage account name. I'll go ahead and select the storage account name. And the reason I'm selecting this storage account name is because this is where my installation script is uploaded. Now, installation script is a new concept for Azure App Service, where the idea is, as Andrew was trying to explain, that you may have a COM dependency, or let's say you just want to do a crystal report installation, or you want to install some libraries, or you may even want to enable certain Windows features. For example, SMTP server. So you will actually create a PowerShell script, give it a name. Right now, the name allowed is install.ps1. You give it a name, and then you create a zip file. Along with this installation script, you will also upload all the required components. So it could be the MSIs or libraries that you want to be installed. Now, once you do that, we will actually go ahead, and once we provision the plan, we will start reading this. We'll download the installation script, and then we will go ahead and then start the installation process in the sequence that you have provided here. So I'll go ahead and select the container. Now, in this scenario, I will actually have to type in the name of the zip file. The reason behind that is that we have secured the access using managed identity. And just to give you an example, this is the storage account that I am talking about. So if I go to the blobs, and this is the container I'm talking about, that's the installation script components install.zip. So I'll go ahead and give the same name. Now I need to select an identity. Now, the reason I'm selecting the managed identity here is, as you're aware, that you could always assign a managed identity for your app. Now you are creating, or you're rather assigning, a managed identity for the entire plan. So the entire communication between the plan and the storage account, and for other things that I will just demo in a bit, we are actually going to use secure communication using this managed identity. I'll now click deployment. Now, again, end of the day, as part of this plan, what we are also deploying is a web app. Now, the code for your web app could very well be in GitHub repo. So that's where you have the experience to go ahead and configure your GitHub repo account. Now, again, when it comes to networking, this is another new experience. And why I call it a new experience is you could always assign or integrate virtual networking with your app. But now what you are doing is, instead of assigning virtual network, or rather integrating virtual network with individual apps, you're actually creating or assigning a virtual network for your entire app service plan. Now, once I have done that, I go ahead and select a subnet. I select default to. Please remember that the subnet that you select here should be delegated to server farm. I'll now go ahead and click on review. Once the review is done, I'll click create. Now, once I click create, What happens behind the scene is we'll go ahead and provision the app service plan. We'll download the installation script using the managed identity and then go through the entire installation process following the sequence of events that you have provided in your installation script. And just to give you a very quick view of how a typical installation script looks like. So this is the installation script, which is just installing all the fonts given in the zip file where this installation script is. And the latter part of the script goes ahead and actually initiates the SMTP server role on the underlying server. Let me go back to the browser. So in the interest of time, I've already pre-provisioned a plan. And as you can see here, this is almost the same plan, just with a different name that I have already created. So you have the storage account, the container, the zip file. And you get here by clicking on configuration under the app service plan. So once you create the app service plan, and if it is tagged to managed identity on Azure App Service, that's where you'll see this new option called configuration. Now you can see I already have a bunch of existing mounts. Once I click on new storage mount, I can give it a name. And then you can see that I have three options. Now the storage mount could be mapped to an Azure file share. Custom basically means if you have a file server over a UNC path, maybe within your own network, as long as I can connect or reach to the file server over the VNet, or it could even be within within Azure, maybe as a virtual machine. So yes, you can use custom file shares as well, of file servers rather. And then if you just want a temporary file share along with your app, that's where you select local. So let me go ahead and select Azure Files. I'll select which file server this is there. Then I'll go ahead and select the file share. So that's my storage account, that's my file share. And remember, as I said, security is one of the most important facets of this entire new offering. So rather than giving the file connection, the file server share connection string as a plain text, we are actually storing that connection string as a key vault secret. And now I will go ahead and select the key vault name, select the secret, and now I can actually give it a drive letter. Maybe I can call it S:" sample mount. So that's how easy it is for me to create a new storage mount, which could be more pointed to a file share or to a UNC path or local. I'll go ahead and cancel this for the moment. Next option is to create registry keys. Now you could actually have your web applications which read or write to registry keys, or maybe one of the installers that you're trying to install writes a license key to the registry. So that's how you can actually create registry keys. Again, you give the registry key path, something like HKey, local machine, the actual hive where the registry key would be created. Again, to get the value of the registry, the actual value of the registry needs to be a key vault secret. For example, if I go ahead here, I would just say the key vault secret, and now I can select the secret. So maybe for my demo application, my connection string itself is a registry setting, and it could be a string or dword. And finally, as Andrew said, that we are actually enabling Bastion, secure connectivity to the underlying instance using Bastion for the very first time. This is where you go ahead and configure Bastion. And another important call out on this page is, while you may have Bastion configured within the same virtual network, but if you still don't want to allow remote desktop access to this plan, you can control that via this checkbox. If I disable this checkbox, then effectively there is no RDP enabled. Now to connect to RDP, I'll go ahead and click on instances. Now over here, if you see, basically you have two options. If I need to restart this specific instance, That's where I click restart. And once I click on restart, I'll go ahead and pretty much re-image and rerun the whole installation script for this underlying instance. Hence, all the apps on this instance will also get restarted. And just to connect or do a secure RDP, I click on connect. Now, using Bastion, you will see that in a matter of moments, we have done a secure remote desktop connectivity. Now, let me open the File Explorer, click on PC. And now, if I want to see all the installation script logs, you see here. So yes, my installation script has been executed successfully. Now, if I want to see all the other adapters, that's where my adapter logs exist. Remember, I did a mount, temporary mount. That's my temporary H colon, where I'm actually writing some logs. Maybe log for net is what I'm using in my demo application, and that's what writing the logs over here. Similarly, I have K colon and L colon mapped to an Azure file share. I can also go ahead and quickly validate registry key. That's it. So now the registry key is also getting written. If I want for troubleshooting, I can also open IS Manager. Now I just want to make a very quick point here and something super critical, that if you make any change to this underlying instance, like an installation or a configuration change using remote desktop, please understand that's not persisted. Because for any reason, if we patch or we make an upgrade, or if there's a restart of the instance, all your changes are lost. So the only right way to make changes is by persisting them using installation script. Because every time we restart or we scale up or we scale out, in all such scenarios, we are basically going to rerun the installation script the step-by-step manner that you have provided. Let me go back to the plan. And this is just my app. Now, what you're seeing here, this is the app within the managed instance plan. Now, the look and feel is the same because this is the standard app service Windows app. And this comes with all the capabilities that app service has to offer you. So you can obviously do an auto scale. You have access to logs. So yes, you have access to everything. You can set up your environment variables, you can set up authentication, your certificate. So yes, it's all there. Nothing changes in terms of the platform maintenance and things. If I just click here, that's my demo app. And you can see it's just any standard app deployment. I mean, you can even do deployment slots. Yes, we also support slots. So yes, as I said, all the features are pretty much there. Now, quickly shifting gears, as Andrew mentioned, that we can imagine a scenario. You have deployed this web application over to managed instance. And now you're also in process of defining modern agentic workflows for your business processes. Now, there are always scenarios and there will be scenarios where you'll do new development, but there'll always be that core piece of functionality. Let's say, for example, a supply chain management piece of functionality, which currently sits as an API. You can actually deploy that API to managed instance and then use that as part of your agentic flow. How we do that? So I'll give you a quick demo over here. How it works is you see a bunch of agents over here. The agent that I'm interested in is inventory manager. So the idea here is I have a sample application that goes ahead and using which I can place order for some merchandise, and the entire inventory management for the fashion assistant app is happening using the API that's hosted on managed instance. So if I scroll down, if I click here, click manage, Next, and you can see here that what I've done here is that I've just created an OpenAPI compliant JSON, got it here as a configuration for one of my agents, and then I've also secured the entire communication between the agent and the API using managed identity. So what I've done is I am still reusing the core piece of functionality related to inventory management for a modern application. And this application that we have is built using Aspire. So your app is built on Aspire. You have agents, and then you have an agent which actually uses an API behind the scene. Let me click cancel over here. And just to substantiate the point, you can see that I actually have the inventory URL as my existing API. And just to quickly show you, that's my Fashion Assistant app. Now, if I click on inventory, sorry, I need to just refresh this app. Once I click on inventory, you can see this entire data is coming from the API hosted on managed instance, and that's my Fashion Assistant. I can just ask a query, tell me about now, behind the scene, what's happening is the entire content moderator agent is branching out, and now it's actually talking to the inventory manager agent to pull the inventory data from the API that's hosted, and there you have the response. So the idea is that you can actually bring in your existing applications, deploy them to managed instance on app service, and then go ahead and make them as part of your modern agentic workflows. With that, I'll hand over back to Andrew to conclude the session.
Thanks, Gaurav. So that was a really comprehensive demo of using a lot of the features with inside managed instance on app service. And I want to bring you back to this diagram of what Gaurav was showing at the end there, where we had the legacy inventory web API running on top of managed instance on app service, all the way secured directly to your AI agents through OpenAPI. So we've got managed identity connecting to that endpoint from the web API. We've got managed identity talking between the Aspire app and anything else in our solution here. And so it's key that we just get that message across that we've been building security directly in with this offering from the beginning. And you are there in that scenario, taking advantage of having modernized that application with zero code changes. We didn't go in the code once there to be able to migrate that application up to app service and then immediately take advantage of capabilities within inside the platform. So in summary, managed instance on app service helps you to move and improve your applications rather than just, as Matt was mentioning before, doing a pure lift and shift. We want you to not only move your applications, we want you to see how you can improve those applications and add new functionality by coming onto Azure App Service. To wrap up our session today, we have some links for you with the announcement details. There's a detailed blog post about all the features and what we were announcing when we announced this at Ignite last week. And then there's documentation so that you can get started. There's some getting started documentation, configuration documents, and some overview. And there's also a sample lab. So you can get hands-on real-world experience with managed instance on app service and do some of the things that Gaurav showed you in that lab. And then hopefully that seeds the feature with you, and you can start to think how you can apply this with your applications. And instead of looking down the barrel of a 6 to 8 month modernization story where you've got lots and lots of code changes to make, you can now shorten that quite considerably. Maybe you can do it in a few hours instead of a few months. And with that, that's the end of our session. I'm going to hand you back to Matt in the studio.
All right, thank you guys. I really liked that session. That last demo was great. I mean, it totally shows off the ability to take your legacy code base, but you're not just limited to that. You can bring in the latest and greatest features and totally use them together. All right, so we have time for maybe a question, maybe two. So I'm going to start off again with something that came up in the chat. And what's the cost of using all this?
So the cost is the same as any app service plan that runs on Premium v4. We decided not to come up with a new billing meter or new billing paradigm for managed instance on app service. So it's the same price as the Premium v4 and the Premium MV4 SKU within app service, which, if I remember correctly, is actually significantly cheaper than our Premium v3 SKU. So there's no increased costs. It's there to make the pricing and the understanding really simple for customers to understand.
Great. Cool. And another question that we got was about something that you were using during the demos is, what is Azure Bastion?
So Azure Bastion is a secure tunnel inside the Azure networking feature set for us to be able to do direct access to RDP. So open sessions using the Azure Bastion protocol product to be able to securely access underlying VMs.
Cool. And then the very last question that we had is, how would you go about like troubleshooting this? Like for like VMs, you can actually log in, right? So what's the process if you needed to troubleshoot anything here?
So you've got all of the same tools that you have with app service today. So you've still got Kudu, you've still got logging, you've got integration with diagnostics, Azure Diagnostics, Azure Monitor, Log Analytics. And key point there to actually call out is in the session guide, I've showed you where the logs get written to the local instance, but you can also suck those platform and console logs directly out into Azure Monitor and Log Analytics and run detailed queries. But because you've also got the ability to go and RDP directly onto the instance, you can also go and use things like event logs. So if you heavily rely on event logs to troubleshoot your application, or you need to go and look at perf monitors that we don't expose directly in the portal at this point, then you can get directly to the instance itself. If you run multiple instances, you can go and choose an individual instance to go onto as well and do more troubleshooting that way. So the goal is if you've got, that muscle memory, that experience that you always need to be able to go and use to RDP into instances for troubleshooting, you can still do that, but then you can also gradually move towards more modern standards of being able to use remote logging. So with Azure Monitor, with Log Analytics, maybe with a third party like Splunk, or maybe you want to use an APM like Application Insights. So it opens up a huge amount of resources for you.
Great. Well, thank you very much, Andrew and Gaurav. That was a great session. And go out and give Azure App Service Managed Instance a try, everybody. So all the links that we had before will again be in aka.ms/agentic-mod, and that appears at the bottom of the screen every now and then, so check it out. All right, so our next session is going to be all about Microsoft Agentic Framework, brand new framework, and we're going to cut right to it and have Bruno tell us all about building apps with MAF.
Welcome everyone, my name is Bruno Capuano. I'm part of the Cloud Advocate teams working in .NET and AI. And today we are going to see how we can use agents to do very, very cool things. So the whole idea for today is that we are going to explore a way that we are going to be able to modernize .NET applications using AI agents. We are going to see how we can take a traditional e-commerce application and transform it and upgrade it to an intelligent agent-powered solution. And there are a couple of things that we want to do when we talk about this. Important one is that there are a lot of challenges that we have today. We know that we have a hard-coded business logic, we have if-else, we have customer requirements that change all the time, we have business requirements that change all the time. We are going to just focus in the hard-coded business rule scenario because we have short amount of time, but it's also kind of an easy way to understand what we can do. With that said, let's start to see what we have today. So let's start to see our eShop Lite application. So this is the application. It's up and running using Aspire. And it has here the full power of Aspire using a SQL Server database, running in Docker container. We have a backend with products, and we have a front end with display. So if we go to the front end and we take a look, this is a very standard application where we can see how we have a list of products here. We can add these products to the cart, and then we have the cart where we are going to have the total, the subtotal amount, and we are going to apply discounts. The discounts are going to be based on the customer membership tier. We have gold, silver, the standard ones, and we also have some discounts applied that are going to be applied here depending on the customer scenario. So right now, in this scenario, we don't have anything. We didn't apply this. And we are going to give it a try, and we are going to see that, hey, this is supposed to be an agent discount applied, but we don't have anything implemented. So let's take a look how easy it will be to implement this. As I said, this is a standard .NET application using Aspire. And here we are going to go back and take a look at what we are going to do, how we are going to work here, what are the main topics that we want to talk and understand. So first of all, this is the main change that we have here is that we are going to describe the intent of what we want to do instead of type and code the line, the how to do the activity. This is super important. Also, we're going to take advantage that agents can make decisions based on the context, based on history. And this is going to give us the chance to basically rely and delegate a lot of responsibility from agents. And we can work with multiple agents. This is going to be one of the key pieces that we are going to see during the process of today's session. Once we say this, we start to see, okay, but let's recap a little and do a super quick definition of an agent. So an agent per se is powered by an LLM. LLM is a GPT model from OpenAI, or maybe now the new Anthropic models that we have in Azure. We can have Mistral models, Meta, and more. So we have an LLM that is going to do the reasoning part of the LLM. Then we have a set of instructions that are going to define how the agent is going to behave. This is going to basically define what the agent is going to do. And at the same time, we have tools. The agent can be connected to external tools or maybe to external database, so they can run code in an isolated environment, connect to APIs to access a calendar, and more. With all of this, the agent can be triggered to perform something. And this trigger can be for a user question. Usually, that's what we see in a chat, in example, or maybe by an application, or maybe by another agent. So there are different ways that we can do this. You can even have a trigger that every Monday, 8 a.m., generate a report to do something. And the output is going to be text, the call to another agent, the call to a tool, or more. So this is the idea. And what we are going to use to create this, and this is important, we are going to use Microsoft Agent Framework. Microsoft Agent Framework is a new framework that we have at Microsoft. It supports C# and Python. Of course, we are going to do the .NET version today. And it's open source, and it's basically focused on get the best practices that we have in the community to work with agents and put them all together for developers like me, where you want to create and use agents. It's optimized for production. It's not GA right now, but it's going to be GA soon. But you see everything that you can expect in a professional framework like traces, observability, scalability, and more is embedded here. And if you wonder where this came from, the Microsoft Agent Framework came literally from the best practice and all of the lesson learners that we have from Semantic kernel and AutoGen. And this is important because this is the place that we have, in example, in AutoGen, a lot of tests, a lot of lesson learning, how we can orchestrate agents. AutoGen do a lot of things, but for me, I really shine in making agents work all together. So everything that we have there, we bring it to the Microsoft Agent Framework, and of course, other stuff that we have also in the Semantic kernel that can connect to different models, different platforms, and more. So everything that we have there is what we have today in Agent Framework. And if you are asking how difficult is to add, to create an agent, it's literally 10 lines of code. Remember that at the beginning, we mentioned that the agents are powered by an LLM. In this scenario, where we have literally the same amount of lines of code in using that in logic, we see that we are going to create a chat client. In this case, it's an Azure chat client. We are going to use a model, GPT-4o Mini, and then we're going to provide the instructions. This is the base of an agent. When we have the client, we are going to say, hey, create the agent. So we have the chat client where we are going to create the agent, and then we can run the agent, async, support the streaming, and more. So it's very easy to declaratively create this agent. And because the agent framework is built on top of very robust and popular frameworks like Microsoft Extension for AI, and also, in example, the C# SDK for MCP, we can add tools that came from the MCP, and we can extend this to use different chat clients. So, in example, if I want to switch from Azure OpenAI clients to GitHub models, I can switch and create an agent that is going to use GitHub models, or maybe local models using Ollama. all of the benefits that the popular frameworks that we have in Microsoft Extension for AI, an example, and C# SDK for MCP are available here. So let's take a look how we can add a very simple agent in our current application. So here I have the line where I have the placeholder where I need to add my discount logic. And the discount logic, right now we don't have anything. So what I am going to do, I am going to delete everything here. And I am going to paste the discount logic. And there is a lot of code here, but let's take a look because it's mostly logging so we can understand what's happening. So we have here a validation that if we don't have the chat client or we don't have the settings and the agents are not enabled, let's return a standard 0 discount. This is the fallback discount that we have here. Otherwise, this is the lines that we know. Chat client, create agent. And we are using instructions and name. These instructions came as part of the definition of the class, where we are going to see here that we are defining that you are an e-commerce prices assistant, that you have some skills in order to validate the membership tier of the user, and depending on the membership tier, you are going to apply some discounts. And then we provide a very two things that are very important here. We are going to define that the agent is going to return JSON as an output. We don't want text, we just want to JSON. We like as a developer JSONs to understand the outputs. And we also are going to provide a couple of samples. This is fusion learning, so the agent works best. And let me start the project so we can take a look right now how we apply this. But let me mention something here too that is very important. In this scenario, what we are going to see is that the agent is going to perform mathematical operations. LLMs are not very good and not the best doing math. So in this scenario, I will strongly suggest, and we are going to see this later, that instead of asking the agent to perform math, even if it's very simple math, like apply a discount, we can ask the model, we can ask the scenario to do more, to instead of doing LLM and math, use a code interpreter tool that is running an isolated environment with Python, create the code that is going to perform the math operation and get the output from there. That's one of the benefits of the agent, that we can modify the agent behavior in runtime, in the agent definition, literally with this. So if we run this operation, if we run this, let's go to products, let's add sample products, and we go back to the cart, we are going to see right now, if we go back to Aspire and we start to see the traces, in the live trace that we have here, we are going to see how the agent now is going to start to work. And one of the first things that we are going to see here is the call to the GPT models. We are using GPT-5 Mini here. So if we take a look at this scenario, we are going to see first the system prompt, the big prompt that we just see, where we define how the agent is going to behave. Then the user question, I have the customer, which is in the entire goal, the subtotal, the list of products, and then the output that the agent provides here. I can start to see step by step what we have, or we can start to see the big one. So this is fun and this is amazing. But the agents really, really shines when we have multiple agents working together. Instead of having just an agent that is going discount, let's see what's happened if we have more agents. If we have, an example, another agent that is going to check the stock for the product. So let's bring back here another sample. And let's see how this sample also creates a new agent here. So we have here a stock survey agent. We have a stock agent here that is going to check the stock. But right now, this agent is not connected to anything. It's literally doing just, hey, you have a product. I am going to give you back some friendly measures with the stock, and that's it. But we need to coordinate. We need to orchestrate the process and how the agent A talk to agent B. So this is the moment, again, where Microsoft Agent Framework really, really helps, because I am going to leave this up and running, because what we have here is the chance, let's go back to the code, is the chance to start to coordinate this, orchestrate this. So I have here a very small agent orchestration definition. What we are going to do is we are going to run an agent, run the other agents. We have the demo 1 here, we have the demo 2, and we're going to run the first agent, get the output, validate we don't have any errors, and run the second agent, and validate that we don't have any errors, process the output, and put everything there. So we are manually orchestrating everything. If I go back here, I go to I go to the store and I add a couple of products. I go to the cart and I apply the AI discount. I will see once again that is going to start to call the different agents. We are going to see more calls here to the GPT models and more. And we are going to have the full process here where we are going to have the full discount applied to the element. So we have the full stuff here, and we see that we have stock agent apply, discount agent validate the discount that can be applied. So we have a stock product in stock, and we also have the discount apply. But we can do more. We can really switch the way that we can do this, and instead of manually use this, remember that we talk about that we have workflows. So let's jump and create a workflow. Let's switch completely the way that we work and create a workflow. But before going there and start to show workflows, let me go back here to the slides and explain a little more what we are going to see next. So when we talk about workflows, and this is important to understand that to explain, there are multiple scenarios that we can see. We can see workflows where we have an agent working next to the other. So we call agent B and then agent A and then agent B, the sequential workflow. Then we have a scenario, more complex scenarios where we have a coordinator agent that is probably going to call one agent, do something with that agent, then get back, call the other, and more. And the cool part about this, and you can see a couple of samples here, the cool part about this is that Microsoft Agent Frameworks supports workflows and support different type of workflows, orchestrations, and different patterns, like an example, the sequential, A, B, C, or maybe the handoff, where you have some kind of criteria, and one agent do something, and then you have another agent that define who is going to pass this and do the handoff, or you maybe have a concurrent, where you have different agents working all together at the same time. You have also Magentic. There are different patterns that we can use. Microsoft Agent Framework support all of them. Of course, in very specific scenarios, one of the patterns should be good enough. Usually you need to understand the domain of your business, the domain of your agents, what is the problem or the scenario that you are working, and apply kind of dual Lego pieces, one on top of the other, to put everything to work together. But it's really powerful and really easy to do. Like in example, right now, what we have here is in the outline, we have two agents. First, the user proxy, that's called the outline agent. And then we have the output from this is running concurrent in 4 agents that is going to generate information for both agents. It's going to have a conversation, writer agent, and the critic agents as part of the writer section because they are running at the right time. This is a sub workflow inside of an agent. There are so many options, so many things that we can do. And if you're wondering how hard it is to define these workflows and more, let's take a look here. So first of all, instead of creating an agent like we did before, every time that we require to use an agent, what we are going to do is we are going to register an agent in the services that we have. So it's going to be available for us to use it anytime. So we have extensions here that allows us to do this. So I have here right now the builder add AI agent. We put an end, we create an agent, and that's it. And if we want to do the workflow, it's very similar. We are going to, this example is showing us to do a sequential workflow where we are going to do builder, add workflow, get the 2 agents that we are going to use, create a sequential workflow, and run with this. It's super simple and super easy to do. So let's take a look at this running directly in the eShop little application. So here we can see that we have the agent orchestration, we have a lot of code here, but the important part is that we have a set of extensions that are going to, first of all, create in this scenario an AI agent. So what we have here is basically create an agent using the chat client that we have. Remember, in this scenario, we're using Azure OpenAI services with the GPT-5 model, GPT-5 mini model, I think, from Azure. And then we are going to create one agent with a set of instructions. In the second agent, remember that we want the agent to validate, the second agent, the stock agent, we want the agent to really validate that there are products on stock. So what we are going to have is an external tool. This tool is literally a class that is going to perform an HTTP client to one of the products backend services that is going to find how many products we have in a store using the product name or the product ID. There are different options to do this. But this tool that is going to be search products stock async, is the one that we are going to have added as part of our agent definition. So we are going to create the AI agent, and the agent is going to be defined as part of what we have here. And then if we can add the tool, because forever, we are going to create the agent per se. We have a triads agent, we're going to see this later, and then we have a workflow, the sequential workflow here, that is going to get the stock agent, it's going to get the discount agent, and when they have the two agents, we are going to create a new sequential agent, and this agent workflow, and this workflow is going to be part of the process. So if we run this and we see how it works, let's give it a try. So right now we have the solution working right now. We have the products and more. We have the traces. This is all based on Aspire. And if we go back to the store and we take a look at the products, we are going to see that we have a set of products. So we are going to apply the same process that we had before. So let's add to carts, 1, 2, 3 process, and then let's apply the AI discount. When we apply the AI discount, if we go back to the traces, remember, this is using the models that are registered, we should see how the model A called the model V, and the model V validating the stock, it should call the external tools. It should call the database. It should call an API that is going to call the tool. And then when we have the response of the tool, we will have the response of the agent. So we have here, we are going to trace here. We are going to take a look at the full step by step. So we have, first of all, the user checkout. So we have, yes, all the items are in stock, but we don't see here any tool call. So we are not doing the tool call. There is something wrong with this scenario. One of the key elements that we have as developers in Microsoft Agent Framework is a tool called DevUI. When we use DevUI, and there are tons of samples that we can do this, we can basically analyze and test in real time the agents and workflow that are registered as part of the application, and we can take a look at what we have. So we see here that we have one workflow, the checkout workflow sequential, and we have here the 3 agents, discount agent, stock agent, and triads agent. So let's go back to the stock agents, at the one that is not working, and let's test this stock agent with a very simple prompt. I'm going to ask the agent here, as equal user, my name is Bob Smith, I bought these 2 products, check the stock, check the products to see if we have them on stock, and also let me know if I have some memberships. As we can see here in real time, the elements, the function are calling. So if we go to tools, we can see that yes, the tool is being called. So it's not a problem of the agent definition or the tool connection to the agent. It's probably mostly like a problem that how we are doing the handoff, the sequential step A, B. Maybe when we are moving from the one agent to the other, then we don't have enough information so the agent can do this check. So we probably need to change the layout, probably need to change the approach here. Remember where I mentioned you that, hey, instead of using a sequential, we probably do this manually, use another pattern or more. This is the moment that, in example, using DevUI, we can test this. And by the way, we can even test here the workflow if we want, and we are going to see in real time how this works. But there is one more step that we want to do before fixing this is, I like these agents. These agents are amazing, and they are part of the Azure Blitz application. But what if I want to use an agent that, in example, is stored in the cloud, an agent that is in Microsoft Foundry? How we can use them? So let's stop this, and let's take a look how we can do this. First of all, let's talk a little about Foundry. So the whole idea of using Foundry is that we can have a full set of everything that we have in Azure, where we are talking about, when we talk about scalability, where we talk about traceability and more, we have a set of tools in Foundry that is called the Microsoft Agent is a service, the Microsoft Agent Service, Foundry Agent Service, where we can create and use agents that they are declared in the cloud. And of course, they have everything there. I like an approach where you can start work with this locally and then you move to the cloud. And if you are wondering, okay, but how much code I need to do to change from this scenario where I am creating an agent locally and then move to the cloud. So it's basically changing the way that we create our agent And instead of creating the agent from a chat client, we want to get an agent that exists in a project that is in Foundry. And let's take a look at the Foundry project here. So here in Foundry, this is Foundry, Microsoft Foundry here. Here in Foundry, we have a project here. It's called Net AI Agent Notion and more. And in this project, we have a set of tools. We can go and start to see which models are available. We start to create an agent, workflow and more. We have OpenAI models here. We have Anthropic models, Mistral, Microsoft and more. And in build, I already have a set of agents here. You can see that I have stock agents. This agent is using a cloud model. It's also using a set of tools because it's getting the information from the product, from the stock, from a set of files that have the product's definition. And if I go to another agent, I can see that I have the discount agent. This is a GPT-5 model that is have enabled the code interpreter. Remember when we talk about that these models are not very good to do math, so maybe we run this using code interpreter, which is very good for this, and it's also available have some memory. These agents have available memory, so we have everything here. We can take a look at the traces of the agent. At any moment when we see a trace of the agent, we can go and take a look, and we will see step by step when we call the code interpreter, what is the question that we have and more. So the definition of the agents is very powerful here, but we can do more here. And remember, Microsoft Agent Framework is literally 2 lines of code to call this. We can even get here and start to have our agents, and we can have a workflow here. We have a set of templates that we can use where we can see and create a workflow that is going to be sequential or maybe human in the loop. This is a very important scenario that is also supported both in Microsoft Agent Framework and in Microsoft Foundry. Or we can have a group chat, or we can start with a blank workflow. In this scenario, what we have is we have the checkout orchestrator. It is going to start first with a question, then call the stock agent, then call the discount agent, and then do a summary of the response. We don't have the summary yet in our application, but it makes sense to have it here. And if we want to try this, we can go to preview. We can paste the same question that we have here. My name is Bob Smith. And when we start to run this as in a very similar way that we have in Dev UI, we will see here that, hey, this is running, and we start to see which agent is working. We start to see the real-time information from the agent. So the stock is done. Now move to the discount. The discount is going to check and going to run code interpreter. So it's going to basically put all of the numbers, generate some Python code, run Python, get the output, and start to move forward. So we have everything there. And we can even see the code. Somewhere here is, I think that we can see the code to do this. And then we are going to have the summarize that is going to put everything all together for the output. If we switch back to our application while this one is working, we will see that for us, in this specific scenario, the only change that I need to do in my application, I already have this ready to do this, is when I am registering agents, instead of register the eShop Lite AI agent, I am going to register the cloud agent and the Foundry agent. And we are going to get again the Foundry project with the endpoint, and then give me the discount agent, give me the stock agent, and give me the trial agent, and of course, give me the workflow. Even so, if we are not going to use this workflow right now, this is the agent working in the cloud. So when we run this, and we have the same scenario, what we are going to have right now in the final demo that we have here is everything running but using the agents in the cloud. But the lines that, literally, as a developer, I really like that I only need to change just the way that I register my agents. There are better ways to do this, I know. But imagine that once you have this, you can literally start to run this, but instead of working locally, you are going to have the chance to use this with all of the agents in the cloud. So I am going to run this, I'm going to have my cards, I'm going to apply discount, and we are going to start to see what we have. By the way, if you want, you can even test your agents from the cloud. So let's test the workflow. I don't know if the workflow is going to work, but I can give and say, hey, run workflow, and you can see here how it's working. So I am going to go back to Foundry to see here that, in example, in the monitor, I can start to see some metrics here, how many times we use this, how many tool calls they were performed here, same with the run and token metrics, run errors. Oh, there are some errors here. We need to see what is happening. Why? Because some of these agents, can't remember one, I think is the stock agent, have some evaluation metrics enabled here. The discount agent have some evaluation metrics here. Oh, one of the agents have the metrics here, but I can see them at any time when we are working and have this. And we can even go further and take a look at this in Azure Monitor, because we have a new preview service that is focused on analyzing agents. So when we have here, we will see that we have a general view of everything, that all of the calls that we have. We don't have any error here. We don't have any consumption. I didn't enable this, but I did enable a couple of metrics for evaluation. So we are evaluating our agents all the time. And again, we have everything out of the box, so we can have a much more better application running without changing any code, because literally Microsoft Agent Framework give us the tools to connect to agents everywhere. So that said, we've seen from the beginner how we can add an agent, pick up an application, move our application to starting to add new features to the application, but instead of typing the application, we are going to use agent in a declarative way where we are going to define what we want to do. At the same time, when we face scenarios like math, hey, the agents are not very good using LLM to do math, but we can use code interpreters. We need some scalability. We need to check databases. Let's use tools to do this. So the agent frameworks really give us the chance to modernize our application as this new feature in a new way, which is really, really powerful. By the way, all of the samples are here. Take a look at these links. I hope you like it. I hope you like it. See you next one. Goodbye.
All right. Thank you very much, Bruno. That was great. We covered a lot of ground there in just a little bit of time. Bruno is one of the most prolific sample creators that I have ever met. And of course, that we will have all the samples that he mentioned that he did at that link are right there below me now. So let's kick it over. I mean, we have Semantic Kernel, we have AutoGen, we smushed them together and they're holding hands just perfectly. But what happens if we put durable functions into the game? So that's cool, right? So everybody knows about Azure Functions, right? It's serverless. We can kick things off, response to HTTP requests. It can respond to like something going into table storage and kicks off an event or a function. And so what durable functions gives us over the top of that is a way to orchestrate things. So like we have an HTTP event coming in. And then what you want to have is maybe a little bit longer running service going on in the background, right? So this HTTP event hits a function, that function goes off, hits something else and runs a little longer, comes back to the other durable function, right? And picks up where it left off. So what it gives you is the ability to do state management, gives you the ability to do robustness as well. So it has this orchestration of functions, right? So what's cool about that then is you put it into agents, is that now we can have agents with state management, right? Has pick one up, right? Kick it off like your discount agent, and you can go check out your stock agent coming back, and so on. So without further ado, let's hear about Microsoft Agent Framework with the Durable Function Task Extension. I think I got that right, but Tiago and Chris, let's hear all about it.
All right, thanks so much for that introduction. So yeah, we're going to talk to you about bulletproof agents with the Durable Task Extension for Microsoft Agent Framework. So I hope you're as excited as we are to learn about this and talk about this. So just an overview of the things we're going to cover today. First, we're going to do a little bit of the motivation, like why did we build this extension? What is this durable tech stack? If you're not familiar with durable functions, we'll give sort of a quick intro into that. We're going to talk about the extension itself for building agents, and then Thiago's going to wrap us up with a really cool demo that I'm excited to have him show.
Yes.
So just jumping right into it, and we're going to go fast because we have a lot of content we want to cover. So why did we build this extension? It's a great question. Glad you asked. Usually when I talk about this, whether it's internally within the company or externally, I like to talk about the 4 Ds: durability, distributed, determinism, and debuggability. These are qualities that a lot of agent frameworks don't necessarily give you out of the box. And so the goal of this extension is to sort of give you those. Now, what do these things mean? So durability, for example, means resiliency from failures. You're running these expensive agentic processes, they're autonomous, You want to make sure that they keep running through the night without any interruption. You don't have to get paged and then sort of restart your agentic workflow if it fails. Distributed. You're not typically running on a single box, which is unfortunately a lot of the samples that you see with agent frameworks out there is just sort of these single machine things. We want you to be able to run your agentic apps in a distributed environment very easily. Determinism, this is my favorite one. This is about, can I build an agentic workflow where I can be very certain about the path that it takes? So, sometimes when you see like agentic workflows, in some cases it's more of like a declarative thing, like a handoff pattern or something like that, which is great for a lot of use cases, but it inherently lacks determinism. Sometimes, these agents may get stuck in loops. It may go down a path that you didn't expect. So determinism sort of gives you guardrails, and that's sort of a built-in piece of what we have here. And then the last one, debuggability. I want to be able to, say, step through my code and sort of watch the transition as I go from one agent to the next, or see exactly what context am I passing from one agent to the next. These top two Ds being largely about the operational concerns, these bottom two ones being a little bit more about the developer concerns. So these are the problems that we were attempting to solve with this extension.
And with the distributed one, given that we are from the Azure Functions team, we like to host things on Azure Functions, so it's interesting that that is one of the key tenets that this brings, because Functions, as you know, as a serverless solution, can scale out and in depending on requests. So this allows the application to scale out and back in down to zero, while still keeping the app distributed and that durability that it brings as well.
Yep, that's exactly right. Yeah. So in keeping in the theme of why, why did we build this? Well, if you're familiar with sort of like the agent spectrum, where on the left-hand side, there's sort of this customization and control. On the right-hand side, you get sort of like fully managed and simple. We sort of feel like we fit sort of in the middle towards the customization and control a little bit. So on the far left, we call that IaaS, like I want to bring my infrastructure, I want to bring my state storage, I want to bring whatever framework that I happen to like. That's the far left. On the far right, you have something more like Copilot. Like I don't want to write any code, just let me configure some agents declaratively and let them go. Now, obviously, there's another option, which is like what we call Foundry paths, where you have options like Agent Service, and that allows you to deploy your code into Foundry and then have your agents exposed over an API, and that's a great option for some. But there's also a set of developers that maybe they need a little bit more control than that. They want to be able to host their agents within their own compute, ideally paths like Azure Functions. But don't necessarily want it behind an API endpoint. And so that's basically what we're trying to target is this you're running on paths and you have a particular agent framework that we offer, but it's self-hosted agents. And with sort of batteries included is one way to think about it. So let's talk a little bit about the durable tech stack in case you're not familiar with durable functions. We call it the durable tech stack because it applies to more than just Azure durable functions, which we'll talk about a little bit. So we'll talk about it a little bit more abstractly. So in the beginning was the Durable Task Framework, which some people may have heard about. It's existed for a long time at Microsoft. It's a dotnet library for building these durable workflows in code. But it's an open source project. We haven't really publicized it a whole lot. So some folks may have heard of it, maybe not. But it is sort of the core kernel technology that we use to build what is Azure Functions, or Azure Durable Functions, which is effectively a wrapper around it. And so Durable Task SDK refers to the different programming models that we have for durable functions. So Durable Task Framework gave you .NET. Durable Task SDKs give you actually multiple languages. So we have a more modern .NET version. We have Java. We have JavaScript, TypeScript. We have Python, of course. We have PowerShell even. We also have a Go. I don't know if a lot of people know that we have a Go library for Durable Task. But anyway, so we have a set of libraries to make this technology available to a broader set of developers. Now, obviously, this is .NET Day, so we'll focus on .NET today. But then the last piece of the tech stack we'll talk about is the Durable Task Scheduler, which we recently GA'd at Ignite. And it's a managed backend which does the state management for your durable workflows, and it also does the scheduling across your distributed compute. So deciding like, hey, this particular action needs to run here, this next one needs to run there. It takes care of all of that and gives you a bunch of really great observability benefits too. So these are sort of the main concepts within the durable stack. And then to give you sort of a sense of what is actually happening when you write your code using durable. Well, first of all, the two main concepts that we show in this code snippet is there's an orchestrator function and then there's an activity function. So this run function here is the orchestrator. The bottom three functions, F1, F2, and F3, those are the activities. The activities are sort of like the main workers that do the actual work. The orchestrator function is the thing that orchestrates the work. And so in this particular example, you can see we're calling some function F1. It returns something back. We iterate over that thing, and we call F2 a bunch of times in parallel. Now, one of the interesting things about writing workflows using the durable functions programming model that's different from other workflow models is that this is completely dynamic. You'll notice that F1 actually returns an array of objects, and then we iterate over that to schedule a bunch of F2 calls in parallel. Now, if you were designing this as a graph, visually, like, you can't really do that because you don't know how many items are in that array that was returned by F1. It could be 2, it could be 2,000. So this dynamic programming model allows you to express a different set of types of workflows, which I think is really interesting. These tasks are also distributed. So for example, when I call F1 or F2 and schedule those to run, these activities, they may run on the local machine. They may actually run across a whole bunch of different machines. And let's say that you do schedule like 2,000 of these F2 activities to run. The dynamic scale infrastructure that runs functions will actually scale you out so that work gets properly distributed. So that's a really important quality of the work that we do too.
We actually have been working with a lot of customers that are now parallel running LLM executions, and they are using exactly this to fan out to, say, 2,000 parallel executions of the same model, and then get the best result back through the fan-in that durable functions it exposes. So it's very, very powerful.
Yeah, it turns out you can do a lot of really interesting things, especially agentic things, even just with durable by itself. But we sort of first class some of these patterns in the extension to make it a little bit easier to get started. But anyways, yeah, so these are also event-driven orchestrations, which is sort of a requirement for the function's dynamic scale. Event-driven is great because when all of those parallel invocations finish, an event gets sent back to this orchestrator telling it to move to the next step. So you don't have to have like this background polling job that's sort of waiting, did all of my 2,000 tasks complete? Which oftentimes causes delays in more traditional workflow systems. And yeah, there's a ton of different patterns you can implement with this, whether it's like chaining of different functions or LLM calls as it may be, fan out, fan in, as Diego talked about. You can build like asynchronous HTTP APIs with this. A lot of different interesting applications. So we talked about the tech stack generally. Let's talk about durable agents in particular, which is sort of the new pattern that we have. So as you guys have probably seen in previous presentations today, Microsoft Agent Framework, it has two main concepts. There's the agents, and then there's the workflows. In the current version of the durable extension, we focus primarily on the agents, which are internally hosted as durable entities. So if you're familiar with entities, you could think of those kind of like actors, if you're familiar with like Orleans and sort of the virtual actor pattern. It's a similar concept, which allows us to take your agents and then distribute them across different VMs in your compute environments. One of the other benefits that we give is sort of these built-in API heads, like you can access your agents over HTTP or MCP, and we're looking at A2A as another option. You can also trigger them using sort of the more traditional functions triggers like Service Bus, Cosmos DB, et cetera, et cetera. We're going to give you some visualization capabilities in the Durable Task Scheduler dashboard, which Thiago is going to demonstrate. Workflows is sort of the next thing that we want to target. So if you are using the agent framework workflow capabilities, we want to make sure that you have sort of the durable benefits of those too. That'll be coming in a future version, so stay tuned for that. And then, yeah, so what does the code look like? This is sort of a hello world sample in .NET. So this is the basic setup. You can see we're just creating an agent using Agent Framework as you normally would. You're also creating a function application like you normally would in the .NET isolated experience for Azure Functions. When you use our extension, we add just another extension method on top of the functions application, which is configure durable agents. And at that point, you can register a set of your Agent Framework agents, one or maybe many of them. And at that point, that's when we will host them for you in the distributed environment and expose those API heads that I talked about. I mentioned that this is distributed, just to sort of give you a visualization of what this looks like. Let's say I have a Joker agent and I have a session going on, which is Joker 1. Because it runs as an entity, it is placed on one particular app process in this distributed environment. And you can imagine, like I'm having a great session with this Joker agent. I'm working on my stand-up routine and getting a bunch of ideas, and I have a really good conversation going. But suppose some scale operation happens or some maintenance, and then that particular app process that it was running on, for whatever reason, it goes down, it dies. The good thing about the durable execution capabilities is that session, that agent session, the conversation and all the state and everything gets transparently moved to another machine so that I can continue interacting with it as if nothing had happened. So all the state that I had, I don't even know that something happened. So that's sort of just a simple visualization of what you get in a distributed compute environment with this durable extension that we offer for Agent Framework. So I've talked a ton. You guys are probably totally bored of me. Let's go to the demo. Thiago, do you want to take it from here?
Thank you, Chris. Cool. So you might have seen this demo before, maybe, the Travel Planner Assistant that used to run the agents on Foundry. But now in this version of it, we want to show you how you can also use it with the Microsoft Agent Framework and what Chris just talked about with the durable extension. So in this demo here, we have a user interface that whenever a customer wants to plan a new trip, they put in the details, and that kicks off a new deterministic agentic orchestration. So like what Chris mentioned before, this is basically coordinating between multiple agents in a deterministic way, and it calls 3 different agents that are specialized for that area. One just does recommendations about the destination. The other one makes the plan for the itinerary, and it also calls a tool. As you might have heard, the agents now, they can call external tools. So this is calling a tool to do currency exchange. And then finally, it calls a third agent called local recommendations. And all 3 of those agents have been defined and created in our code using the Microsoft Agent Framework with the durable task extension. And then finally, when all of those are done, we summarize, we create everything into blob storage, and then ask the customer if to review the itinerary and tell us if they wanted to book the trip for them. And then if it's approved, the booking system finishes, and that whole orchestration then finally completes. So let's have a look at what this looks like in the Azure portal and in the code. So here I have the demo deployed already to Azure. You can see here we have quite a few things like Azure Foundry to host the model that we're going to call from our agents, the durable task scheduler for the backend, and our function app. And if you see here, our function app is a flex consumption function app, which is a serverless hosting model that we have that can scale very fast and scale back down to 0 when it's not executing. And it's running all of the functions that we have defined in our code for the durable orchestration and everything that it needs, including the API that it exposes. And as Chris mentioned, each agent gets exposed as an entity, a durable entity here. So here they are, all three of those.
Yeah, and you may notice that prefix there, the DAFX, that's DAFX, or the durable agent framework extension is sort of one way to think about it. But yeah, those are all entity triggers, as I mentioned earlier.
Right. And then as part of the solution, like I mentioned before, we also have a static web app here that's hosting our front end. So let me go into that app and kick off a new trip. So Thiago, trip to Japan. I know you're a very big fan of Japan.
I love Japan.
For a family of 3. And I'll do a moderate budget, not too much, and then maybe May 2026. So when I kick this off, it's going to pass it on to my durable orchestration. And this here is actually the orchestration ID that this UI is then going to start polling the orchestration as it progresses and starts working through all of those 3 agents that we have. So while this is going, it's going to take a little while to call the agents and summarize everything. Let's have a look at our durable orchestration, durable task scheduler here that has a task hub where the backend for those orchestrations are running. And I have the task hub here, and I'm going to refresh it. And now it shows that orchestration that I just kicked off from the UX is running. And I'll show you here how it's starting to run the agents. While our orchestration is running, let's have a look at the code. So here, locally on my dev box, I have the same code running with the function app started up and all those same agents running locally. It's also talking to the durable task scheduler emulator and also the Azure storage emulator. So if we look at our local settings file, there's no connection strings. It's only an endpoint to OpenAI, and I'm using identity to connect to it, so it doesn't need the connection string.
Yeah, no secrets.
No secrets in our files anymore. And locally, talking to development storage locally, and then the emulator here. So what I can do is, locally, I can start a new travel planner here. And this is just our API endpoint showing that it's going to start the booking. And if we scroll down a little bit here, we can see that it's scheduling a new orchestration. So that's the one that's going to take care of creating everything for us. And here we see the ID. So it's similar to the ID we saw on the UI. And then it's going to start creating all of those different agents for us in program.cs. Oops. So here's where you can see, let me make some room here, where we're creating those 3 agents in the code as part of configuring durable agents, just like Chris showed in the slides. So we're creating one agent for destination recommendations, one for itinerary planning with some extra informations. And this one is pretty cool to me because we have 2 tools here available for it to use to convert the exchange rates between, I guess, Japanese yen and US dollars. And then here, the final one, local recommendation agent. So it's setting up all of those agents for me.
And so in all of this setup, this is just standard Microsoft Agent framework that you're setting up and then just registering it with the Functions app, right? Okay.
So here we're doing it inline as part of the call, but we can also pre-create the agents in the code and then reference them here. And as that's running and creating my endpoints, I can also make a call here to get the status of how it's going. So now it's doing the same that my website is doing and making calls. So let's go back while this is running locally. Let's go back to the one that we started on the web app to see how it's going. As you can see, it's already ran a few agents, and it's on a timer here waiting for something to happen. So I just wanted to show the 3 agents here. If I look into the itinerary one, it's pretty interesting. We can see that it called the exchange rate here to get what the rate should be. And finally, because it's waiting, that means that I can go back to my web app and it actually shows me the whole itinerary that they planned for me in Japan. Does that look good, Chris?
Yep, let's do it.
All right, so I'm gonna approve it. And that basically means that my orchestration is complete. I can refresh here, and now it shows as completed. So that's the end-to-end of the whole solution running both on Azure or locally here on my developer machine. So if I check the status of my local one here, it would have moved on and still now creating a detailed itinerary. This one is for Lisbon in Portugal. And as it completes, I can then send events to it to say, let's complete it too. So end-to-end durable solution for your agents. And I really like the deterministic approach that we have here, where you kind of guide the solution as to where it should go and run all of the agents for us to give us a pretty awesome itinerary for a trip to Japan. With that, let me go back to the slides. And just wanted to thank you guys for watching this. We have a few interesting links here for you to check out. The first one is the blog where we talk about a little more about the durable extension for agent framework. You should definitely check that out. Our coworker Nick wrote a really great blog post there, so make sure to check it out. A link to where this demo is. We're making a couple of extra improvements there, but it's all there already. You can try it out yourself. And then finally, just a general, .NET agent links to all the demos that are being shown today. With that, thanks everyone, and we'll see you next time.
Great, thank you, Chris and Thiago. That was great. I love how functions makes everything easier, and especially now we get the durable functions and making the whole agentic orchestration easier. We got the durable, and I think what you mentioned, Thiago, at the end with the deterministic, we kind of like they just don't run wild anymore. We can kind of put them down in a bowling alley. We got the gutter rails up for them, so that's pretty cool. So one question that did come in is when you're creating the agents, and this is probably more of a MAF question, is that are we limited only to using the Azure OpenAI client when we're doing this, or can we go out with any model?
Yeah, so any model. We just happen to use Azure OpenAI because that's a great choice and sort of gives you the option of the secret list configuration and things like that. But yeah, we're not limited to that. Microsoft Agent Framework supports a wide variety of models, and you can use all of those models with the durable agent extension, no problem.
Great. Well, thank you very much, Chris and Thiago. Everybody go check it out. Durable task extensions for Azure Functions for Microsoft Agent Framework. I got that name wrong, but it's going to be in our links. And we have the blog post, we have the samples, everything else that you need. So yeah, it's super cool. Run through that sample. It's amazing. All right, so next up on our events today. So we just talked about how we can actually make a deterministic a little bit, kind of keep our agents on the happy path. But what happens? What happens when our autonomous agents decide to do whatever they want? And we kind of have like little urban legends of agents, like they might go out and they just delete all our data, or they just decide that everything, they're rogue, they're going around. How can we protect our enterprise data? And so our next guest today, Davide, is going to talk about how we can protect our enterprise data with Azure SQL or SQL Server. So there is a bunch of different things that we can do with it, and so Davide is going to run through this stuff and talk about how we can implement some best practices like least privilege access to make sure that we don't get unauthorized data exposure or anything like that. So I mean, it's all the stuff that you really kind of want to do when you're just doing regular app development and you're doing regular making sure that people don't have access. Like me, you don't want to give me access to your secure data if I'm just a regular employee. So you want to make sure you have all this same stuff set up for agents, because sometimes you don't know what they're going to end up doing. And so, Davide, how about we talk about making sure your Azure SQL data and SQL Server data stays safe?
Yeah, thank you, Matt. It's great to be here. I will be showing you as much as I can as soon as my computer unfreezes. Hopefully now, perfect. So good. I can start projecting, the trail of the live, and here we go. So yeah, that's right. I will be discussing a little bit how you can secure your database and your data to make sure that the agents that are basically going and do their own stuff will be doing it in compliance with the rule that you set to make sure that your data access is secure. So let's start with the Agentic AI challenge. Then we'll go over row-level security to make sure that you can, sleep at night in peace and being sure that your data is securely protected by Azure SQL and SQL Server, no matter what agents will be doing. And then we'll also discuss how you can actually use the newly announced SQL MCP server tool to make sure that your database can connect to AI Foundry, for example, so that you can build a very nice agentic application in a breeze. So let's go over it right away. And let's start with the Agentic AI challenge. Well, the main point is that things are changing, as you probably discovered already. And AI agents will actually write and execute SQL code for you at runtime. This means you don't have control on SQL code that gets executed anymore. And while that is great, because agents can really do fantastic stuff, I'll show you some samples, that's also a little bit scary sometimes, right? Because before this new year we are entering in, before these days, so let's say in the old days, before AI agents, you could trust your developer to actually write the right SQL code with the right where clause to make sure that whatever application I'm using, I will only be allowed to access what I need to access or I'm allowed to access, right? So the application will just run a query on the database, make sure that the right where clause with my name or my ID, it's always added to the query being sent to the database, and everything is right. But now with AI agents, you will not write, or none of your developer will write SQL code, because you will tell agents what you do, what you want to do, and the agents will actually write the SQL code for you. So how do you know, and how can you be sure that the agents will actually put the right where clause whenever it's needed, for example, to comply with security? And even if they do, how can you be sure that no one is using a malicious prompt or maybe just wrong data, or again, there could be attack using data injection with malicious data in your database, maybe that kind of tricks the AI agent to do more than it should be doing. Or maybe you decide to use something on premises, you are experimenting with a new model, and it's not smart enough to actually understand how to apply the security to your queries. So you need to figure out a way to do it once and for all, no matter what agents are using, no matter what LLM, no matter where the agent is coming from. And that's how you actually sleep well at night. But before going there, let's see the nice and fun part and super cool, I would say, part of agents. So let me move to my code. All the demo I'm showing is also available on GitHub. You will get the links later. But basically what I've built here, since I'm more a backend guy, I built a console application where you can chat with your own data. And I created two agents, and that's very important. One orchestrator agent that knows about all the tables in the database. Because we discovered, and probably you realized already, that if you just throw the entire schema, and if the database is not trivial, like the entire schema can be a lot of tables, like 100 or even 1,000. So if you throw the entire schema to the agent, at some point it gets confused, right? Like humans. If I want to have the solution for some queries I'm running, I may need only to focus on few tables, not the whole tables that I have in my database. So we have two agents here. One is what I call orchestrator, that knows about all the tables in the database, but at a very high level. So it knows the existence of table A and table B, let's say sales and customers and products, and it doesn't know exactly how each table is done. It doesn't know about the schema, it doesn't know about any peculiar kind of ways to query those tables, but it just knows that the table exists and what is the purpose of the table. So this is the orchestrator, and it's the one that you will be discussing with in order to tell him or tell it what you want to get done. And the orchestrator agent will figure out the steps needed to answer your query, and it's all defined here in the prompt that the system prompt I'm passing to an agent. So the agent, can break the request in smaller steps, and then can use another more specialized agent, the one that I call the specialized database agent, that instead is able to only see a subset of tables the one that are specified by the orchestrator agent based on the request or the steps is taking to satisfy your request. And for those tables, the specialized agents have access to everything, all the metadata, all the information, all the schema, details, everything, right? So the specialized agent will actually be the one who is creating the query, right, and running it. So there will be some back and forth between the orchestrator agent and the specialized agent to basically work together to come up with a solution to your queries. And your query, actually your natural language query, can be something pretty complex, right? Like, let me show you. So let's start this application in debug mode so we can see also what happens behind the scene. And this application is right now using Semantic kernel. I will soon move it to the agent framework, but the principle is pretty much the same. So here I am accessing to VentureOS 2025. I'm using SQL Server 2025 on my machine. I'm using the SQL Express edition, which is free to everyone. And you can do the same also in Azure if you want, because we also have a free tier in Azure. And so it's up to you to choose where you want to run this, but I'm just using on-premises for the sake of this demo. And my orchestrator agent has been informed about the existing of 66 tables. So not really a trivial situation, but still not super complicated, but good enough for this demo. And now what I want to ask, and the prompts again are part also of the example, I want to ask if the agent can help me to figure out what is the best selling product in each market we operate, because I'm assuming here I'm using this database that is from my company that operates in a worldwide scenario. And then I also want to understand what would be the cross-selling opportunity with another product in each of those markets. So literally not something easy to ask, right? And that's exactly what people want to do today with AI and data. They want to talk and discuss with their data. So let's see how it is behaves. So let me put it full screen, and basically I just asked the question. So now the orchestrator agent came up with a plan. So these are the tables that it needs. And then these are the two steps that it needs to accomplish. So now that the orchestrator has a plan, is moving to the specialized agent to ask something more specific, like the orchestrator is asking the specialized agent, return the best-selling product by total sales and quantity or amount in each market, and blah, 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 right? And use these tables because those are the tables I know out of the 66 that we have that are those the ones that are relevant for answering this question. And then the specialized agent can start and run a query, even a complex one, right? Here is really using advanced techniques like row number and partitioning, aggregates, and starting and going on. The original request was split in two different subtasks. So that's why you see two different queries, one with the interim result and the second one with the other interim result. And then the specialized agents are returning the result of these two tasks to the orchestrator. Orchestrator is putting everything together, and now we have an answer. That is fantastic, honestly, because this is exactly what every customer I discuss with want to do. Talk with the data, be able to interact with the database in a natural language, brainstorm, find insights. And that is where everyone is, wow, this is what I want. But then immediately after that, usually someone start to ask a more security-related question. And those are, well, what happens if, you're a good guy, Davide, but what happens if by mistake or because you want to force a little bit the hand of the system, you start to ask questions to the orchestrator or even to each specialized agent, something that you should not ask, right? Something that maybe allows you to get insight on some data you should not be able to see. For example, in this database, we have data from all regions of the world, but I am in the Pacific Northwest, so I may assume that I'm only allowed to see data from the Pacific Northwest, right? Maybe I'm trying to, do something strange or something interesting with another region, let's say France, and I'm trying to sneak in some request about France that I should not be seeing, but I'm trying to force my agent to actually give that data to me. And luckily in SQL Server, since ages, so more than 20 years ago now, we have row-level security. Row-level security is the answer to all these security challenges that agents start to bring into play, right? Because with row-level security, even if you have a query written by you or written by an agent that completely lacks a where clause, you will only be able to see, or the agent in this case will only be able to see only the rows that you want it to see. Let me show you. It's easier said than explained. So let's go here. Let's go back to our solution. Let me stop the application for a second because I want to go for a second to database. And here I have my row level security configured. It's not very complicated to set up. It just requires most likely a table where you want to store, for example, who can access to what. So let me show you this new table I created called security, says territory access. Let me connect to my SQL Experts database here, and specifically to the right database. So AdventureWorks, here we go. Let me execute the query again. And you can see that my account can only access to territory, or it is at least what I wish, should only be able to access the territory 1 and 4, right? And since my agent will be acting on my behalf with my security in this specific sample, basically I just want to have the agent to have my security level. So that's why I assigned the security level to me. Now, what I need to do is set up the row level security, which involves creating a function in SQL that filters the rows, and then creating the security policy and applying that function that filters the row to each table. Now, the function is not really called by each row, because that will be too slow, but logically we can think something like that, right? So every time a row is about to be returned to the user, this function actually act as a filter deep in the engine, so that the row is checked with the permission if it should be returned or not. Again, this is just logical. Practically speaking, it runs in a much more efficient way, but ideally that's what happened. So right now, let me make sure that the policy that I set is off for now, so I can take any query. Let's say I have this query here, and I applied the security to the sales territory. I run my query. Again, let me connect to the database, but the right one. Here we go, and let me run the query again. And you will see that now I can access all the territories, which is not what we want, right? At the same time, I can also access all customers, because it doesn't really matter in which territory they have. I have full access to all the database here, but that's not what we want. What we want is make sure that I can only access the Pacific region of the territories that I have. So what I need to do right now, I already configured, as said before, the policy. I just need to enable it. So let me go and turn it on. And now I can go back. I'm logged in as myself, which, by the way, in this machine, I'm the administrator. And now, even being an administrator, let me show you what happens if I query sales territory, no filters, no other options to filter data. I can only see what the policy allows me to see. And maybe you can think that I can play some trick and say, hey, let's do where 1 equals 1, so we can kind of trick the query optimizer. Well, the query optimizer can't be tricked in this case. It still shows me only the rows that are compliant with the policy I have set. And the same is for customers, right? So now I can only see all the customers that I want, but as long as they are in the sales territory. Now let's go back for a second. Let's do one sample here. Let's first of all disable the policy again, now that you understood how you can enable it and how it works. So right now we are back to the square root, so where we are completely free to access everything, and let's just run our little application again. And so let me run again this here, again in debug mode, so you can see what happens behind the scene. And I will use another prompt this time. I have prepared this one, so you can easily see what happens behind the scene with and without the row level security enabled. So let me ask the AI agent some help in analyzing something in France, where I should not be able to have access to. And the AI agent here is absolutely, happy to help me and get data about all the details of sales in France and who is doing what, all very sensitive data, right, that I should not be able to see. So let me stop the application. I could have also just cleaned the memory of my agent, but just to start fresh. And now let me enable the policy. So turning it on. And let's run the application again. And let's see what happens right now. So let's ask exactly the same question. Let's see what the agents came up with, probably the same query. And now it appears that there are no recorded sales for France territory. So this makes sure that the agent, even if it's, in this case, rightfully so, trying to apply a search for France, in this case using the regional code, is still not able to see and access any data it shouldn't access since it's acting on my behalf, and so everything is secured. And again, remember that this query here is not something is written in your code, as we have learned in previous sessions. This query will be created by the AI agents, so you don't really have a lot of control on it. Yes, you can try again to force some workflows with the prompts and maybe put double check, but the moment you try to constrain too much what the agent can do in terms of creating SQL queries, you also limit the capability for the end user to interact with the agent with your data, right? So you don't really want to limit that much in terms of capabilities and flexibility, but you do really want to make sure that the security is always applied, no matter who writes the query, how the query is written, and who is going to execute it. So this is, I think it's the absolute feature that you need to keep in mind whenever you think of creating an agent that can access your data and you plan to allow the agent to write arbitrary SQL queries for you. Of course, if you use store procedure and function, you have a little bit more option. But again, using those features in some case might be limiting. So if you really want the agent to answer, as I'm doing right now, any question, you need to let the agent create the SQL for you. And then you need to have row-level security and all the other security objects that you are probably already aware of, like column-level security, the object security, to make sure that agents can only access what you want them to access. Now, with that said, let's move to the next step of this short presentation, which is about, this is great, Davide, but I will be using most likely AI Foundry and agents, and I don't really want them to be able to just write random SQL queries, because again, that's exciting, but maybe I have a use case where it will be much better if my agent can actually see the database as a set of tools exposed via MCP. That is great, and in fact, we have created a SQL MCP server, which is in preview right now, and is a self-hosted container, basically an application that allows you to take your database, select the storage procedure, select the entities that you want to expose, and turn them into tools that can be used by MCP. So this means that any agents can safely and securely connect to the tools that are exposed via the MCP. It's horizontally scalable because this solution can be hosted in a container. One of my favorite way to host the Azure Container Apps, and it can easily scale horizontally. And of course, it's secure because this solution is based on something called Data API Builder that allows you to exactly regulate how do you want to expose your database as an API. Data API Builder always supported REST and GraphQL, so you could even today take your database and turn it into a GraphQL service or a REST service, just like with a flick of your finger, because it just takes a second. But then you can also make sure that you have a deep and well-defined security layer, again, provided by Data API Builder, so that you can choose exactly who can access what using the claims that are provided when you perform authentication. Now, to GraphQL and REST, we added support for MCP. So MCP, again, it's in preview. It's very easy to set up. It's basically you download Data API Builder, which is a .NET application, configure a configuration file, just to tell the Data API Builder what should be exposed and what not, what are the security condition that you want to apply, and then basically you even enrich your configuration with semantic notation, so you can describe what a storage procedure is for, or what is the table purpose, or what is a view purpose, so that the AI can have as much as information as needed, and then you just publish it on Azure Container Apps in my specific case, and then you have an MCP endpoint. MCP endpoint that you can use, for example, for testing. I'm using VS Code, so I can see the tools available, or you can connect to it from AI Foundry, which is exactly what I'm going to do right now. So I'm in AI Foundry here, and what I did is that I just created a tool in AI Foundry that connects to the MCP endpoint created by Data API Builder, hosted in Azure Container Apps. And now I can start to chat with my data saying, hey, I want to find a good product for a teenager boy passionate about Formula One. So the agent is now using the scribe entity to figure out what database expose. And then he's asking me the permission to execute the storage procedure search products. Store procedure that, by the way, internally is using vector search and the RAG pattern to actually provide a rich answer, not just a simple where clause. And then it's returning the data. And here we have, for example, the answer that says, yeah, from your product catalog, I see you have F1 for PS5 or Xbox ROG Ally. That's definitely a great choice for your teenager boy. Now, how this helps you to build great solution. This is what we envision the modernization is for existing application. Let's say you have your insurance solution where you can manage your accounts, right? So what happens in future is that you can add a chatbot experience, but you want that chatbot experience to be integrated with the rest of your data and your solution. So here you just ask to list your customer, and you notice that one customer needs to have some updates. For example, John's name is actually Marcus. So, because there is an error in database. So you chat with it, or maybe in future you will talk with it, and the agent will actually call the store procedure or issue the right SQL command via an MCP call that is exposed, as I just showed you how, and then correct the data. And then you immediately see the answer in your application. Then maybe you add or update other information about like new ring added after wedding, and more details, so everything logged, of course, because you want to have a trace of what happened in the database to make sure that the agent is always helping you in a way that you can always understand what happened in case you have to figure out something later. So this is the architecture that I'm super excited that it's doable today, right now. You have SQL Server, Azure SQL, Fabric SQL, all able to host AI features inside their engine and connect to OpenAI, and then you can take your store procedure view or table, expose it as a MCP endpoint via Data API Builder, and then connect it to AI Foundry to basically build the agent of your dream that is secure, capable to answer any question and access the data in the way you want it. This is what we have built for you, and if you are a developer asking, that's great. Now I want to deploy it from on-premises like you did, David, in the cloud. What is database I should use? I go to Azure and I see a bazillion of options. Well, the answer is very easy. Go with Hyperscale. Hyperscale is a database that we have re-architected to be cloud-born. So it's Azure SQL Server, but with an Azure SQL kind of approach, so everything is distributed. It can scale as much as you want. It gives you the peace of mind that you can grow as much as you need and do all the AI kind of features and evolution that you want with the peace of mind that you don't have to change or re-architect your database if you grow more than what you expect or as much as you expect. And then I have some resources here. This demo is available for you to download. It completely works on premises. If you want, you can even use Olama to run everything completely on premises. I was using OpenAI today. But then there are many questions usually that comes after seeing this. So where I can download the API Builder. I have some question about how to design my table, why you choose orchestrator and a specialized agent. And so you have all the questions answered in the articles FAQ on AI and vectors, developer edition, link to download the latest and greatest 2025. Plenty of AI samples. We have 61 samples reached with SQL and AI. And then, of course, also the Azure SQL database offer in case you want to deploy everything in the cloud for free. That's pretty much what I have for you. Make sure to connect on LinkedIn and Reddit. And thanks a lot for listening. I hope you enjoyed it. Hey, Matt.
Davide, that was great.
Thank you.
All right, thank you very much. I always love hearing about Azure SQL because every time, especially from you, I learn like 15 new things. It's amazing. So we did have one question coming from the chat, and you did kind of get to the answer of it, but I do want to reiterate it.
Yep.
Let's say I am the software developer with the horns, the bad guy.
Yeah.
How do you avoid me doing some prompt injections or stuff like that? What's the way to get away from that?
So I'm talking now. I'm putting my PM in SQL hat, and I can't basically block you or avoid you to do prompt injection, right? Because there are so many ways to do it. Yeah, I can do something, but the real answer is make sure that your data is secure and never leaves database if it's not intended to do. in the sense that if I ask data about France and I'm not supposed to see data about France, the data should not never leave database and be brought to the application and then filter there, which is sometimes what happens. Or it should not be the application adding the where clause, because as I said before, maybe now you are not writing the SQL anymore, agent will do it for you. So you need to protect the data where it is, putting a gate in front of the outside world, and just make sure that SQL has the row level security, column level security, object level security apply correctly, so you can sleep in peace without any worries.
That's great. And I'm going to do one more question. I told the team I only had one, but I'm going to do one more because I just wanted to throw my curveball. So were you using VS Code plus an extension, or were you using
Correct.
SQL Server Management Studio?
No, that's a very good question. I love both, of course, but here we are in the developer space, so I went full in VS Code, which is great because I can go from SQL and C# code or Python or whatever you want to code with in just the same environment, so I don't have like the friction and the additional burden in my mind to switch from one tool to another. So the extension is called MSQL. Very easy. You can look for it in the VS Code extension marketplace. It's free and provides everything that is needed, even a nice table designer, and it's also integrated with the Copilot. So every developer can just write what they want and get help in getting SQL written. They can see the design of the architecture of database. So it's very, very nice, and we are getting amazing feedback on it. So just make sure to check it out.
Great. Well, thank you, Davide. Really appreciate it. So making your data secure with Azure SQL, or the agents, making sure they don't run wild with Azure SQL and all your data. All right, so we took care of the persistent data. So what happens, though, with the data that you want to be able to access very quickly, right? Cache data. And that's where Azure Redis cache comes in. And so what we're going to talk about next is making sure that your data in Redis, in your cache, is secure, it's fast, and we're going to talk about the latest patterns that we can use with Redis and .NET to make sure that we can both build agents and that we're all up to date. So Catherine is going to be here to be talking about that in just a minute. And so Catherine and I actually did a session on Azure Redis back in .NETConf about it as well. And so we built a couple agents to show that off. And it was, if I do say myself, one of the sessions I gave, it was great. Catherine is awesome. I was just there for comedic effect. But yeah, so we're going to be looking at, Azure or Redis can use MCP servers and everything else. You saw a lot about MCP servers today and how that can actually make the whole development experience a lot better, because it gives you, I don't want to say it gives you more intelligence, but it does give you access to other tools that can add functionality to your development experience and so on. So with that said, I believe that we're ready to throw it over to Catherine and talk about building secure and smart apps with Redis.
Hello, everyone. Thanks for having me. My name is Catherine, and I'm a product manager in the Azure Redis team. Today, we are going to talk about using Redis in your agentic modernization process. Basically, how Redis can help securing and accelerating your application when you move it from the on-prem old .NET stack to cloud using the latest .NET framework. In addition, after the modernization process, if you would like to extend your application system to incorporate intelligence into it, like large language model, make it agentic, Redis is the perfect data store to help you complete that journey. So let's start. Today, we're going to look at what is Azure Redis and how Azure Redis is secure by default. Because when you move from on-prem to a cloud environment, a lot of customers wonder, how would my data stay secure with all the resources and everything shared in cloud? We'll answer that for you. And then how Redis plays a role in the application modernization process. We will look at two examples that would cover about 90% of the scenarios for getting you started to be scalable, performant, resilient in Azure. We will look at two demos. One is on the modernization. The other one is on extending your system to make it smart. So Azure Redis overview. Redis is a well-known in-memory data store, and we fully manage it in Azure as a first-party application, first-party resource. So Azure Managed Redis is our latest offering and the offering we recommend going forward. It is fully managed, secure by default, first-party supported, scalable, resilient. You can learn more about it at this link, aka.ms/Azure Managed Redis. Let's take a quick look. This is the Azure Managed Redis pricing page, which the aka.ms link actually forwarded to this one. And you can see we have 4 different buckets for the product. Memory optimized means you get a lot of memory and then like a relatively lower number of CPU to memory ratio. Balanced is just about the right amount of CPU versus number of memory in gigabytes. And then compute optimized is for the type of workload that's like compute intensive. So we map the most amount of CPU with the memory. Flash optimized is another type of offering that optimized for the scenario where you have a lot of data, but you don't really care that much about performance, in which case we use the flash memory instead of in-memory to lower the cost. You can see we have pretty good coverage in terms of the amount of data size we can support. So for the in-memory, it's as low as 500 megabytes all the way going up to 2 terabytes. And then for flash optimized, it's a wider range. And you can get started at a really cheap cost. So with the balanced tier B0 SKU, you can get started for as low as $11 per month, about that much. So go check it out. Everything's available in Azure, can be provisioned through Azure portal. Azure Managed Redis is secure by default. So when you move your data from the on-prem setting or some server that you have full control with to a managed service, you may wonder, how do I make sure the data is secure? There are 3 top features that we offer to ensure data security at the computation level. We use Entra ID to make sure there is no password required when you write your application code. Everything is done by service-to-service authentication, which is a standard across Azure. The network level of security. This makes sure your data transfer process is secure. So you can now configure the public network access restrictions on your Azure Managed Redis resource and securely integrate it with a virtual network environment through private endpoint. Encrypted data persistence. If you ever care about the in-memory data being persisted, like if you restart, if the server gets restarted, somehow your data is still there, there's a feature for persisting your in-memory data to the disk of the physical server that hosts the Redis service. So if you ever choose this option, we provide the persistence layer of security by allowing you to encrypt the data, and you can encrypt use your custom managed key. We will take a look at this in the demo later. Also, a few more concept slides before we get into the demo. We're talking about agentic app modernization today. So this slide may look familiar. This is the standard process for modernizing your application. The first 2 boxes are about making sure you use the latest framework and the latest dependency libraries. In this case, we highly recommend you to keep your Stack Exchange Redis up to date to the latest version in order to receive all the performance and the security enhancement. The next 2 boxes are about converting your app from on-prem to the cloud environment. This is where a little bit of refactoring your code, adding dependencies, re-architecting would be required because the on-prem environment is in nature different from cloud. Cloud is more distributed, and you usually have to think through the dependencies and then the performance among the dependency services. That's where adding Azure Redis would come into play. It makes your application more performant and saves the cost when it runs in Azure. There are some examples that will be handy when you think about migration. So this is about move data from local memory to Azure Redis. One of the pattern for hosting in the on-prem is like you have your application code running. It's on top of some application web servers like dotnet IIS, for example, and then memory and the storage. These are the local resources. So when you run everything on like one on-prem web server, it's actually fine. Your application code talks to the memory directly, and everything's cached locally. Versus when you go to Azure or any cloud environment, what you should consider is make the memory from local to the external distributed. One big advantage is it keeps your application resilient. When you restart your web server locally, like everything in memory might be gone, right? Versus in cloud environment, because there are a lot of moving parts, the environment is by nature more dynamic. Even though we try to not restart the resources as much as possible, like restart happens seldomly, but when it happens, everything in memory in this web server will be wiped out. Versus if you have it in Redis, the experience is a lot more resilient. Okay, so the next scenario is about data acceleration. Again, in this hypothetical environment here, if your application code runs locally and have really fast access to the memory and the storage, and you host data, say like in the SQL interface, something like locally, performance may not seem to be as big of an issue, especially when you run the repeated queries, because the wires are a lot closer, like when you access from your application code to the local hardware. Versus in Azure, everything is distributed. The web server and the SQL may run on different like hardware by definition. So when you run repeated queries in the cloud environment, there will be more significant performance hit. That is when you want to add something like Redis to cache the query result, so everything will be faster. You don't have to run the repeated SQL queries anymore. You can directly fetch it in Redis, and most likely the data is stored in memory for Redis, unless you choose the flash memory, but it's still a lot faster for returning any results. And there are just more examples for when you move your application from on-prem to cloud environment, how you can apply Redis resource to accelerate your data performance. The first scenario, the web output cache. This is about when your application needs to generate complex HTML output, it may burn a lot of CPU. But you can cache the HTML like web response output in Redis to make the UI rendering easier, like faster. Distributed cache. This is what we talked about earlier. When you have to query for all the product, for example, in your database, you don't have to run the repeated queries over and over again. You can just cache the query response. Session store. So when you want to store anything specific to a user during a session to improve the performance, just save everything in Redis. That way, in the case of a like unexpected failover, this data is still persisted. And that helps to retain your customer, make sure the experience is optimal throughout the user session. Next one, leaderboard. This is a really popular scenario. Redis offers a data structure called a sorted set, where you can associate each entity with its core, and it's just sorted in real time when you display this data set. So this is useful in any like e-commerce, gaming, or finance, and a lot of other applications when you need to show a list of like top players, most sold products sorted by order. And you may wonder, like we hear about caching a lot, but not everyone knows the right way to do caching. So we made it super easy by introducing the hybrid cache library. This was first introduced in .NET 9, and we enhanced the support in .NET 10. Basically, the high-level idea is when you want to write your application code to like check if something exists in cache already. If not, run it in the database or fetch it from some API, web API queries. If yes, just return from cache. You don't have to repeat this application logic over and over again. This library, as we will show later, makes the interface very simple. It's just one line of code, like get or create, to automate the logic for checking cache first. If not, go to the backend data store. If yes, return the query. In addition, there's a huge advantage for using this library because we are leveraging both the L1 cache and the L2 cache. There's some like a smart combination we're doing to make the really frequently access the data just be saved in memory for the super fast access. Meanwhile, it's also persisted at the second layer, the cache layer, which can be configured to be Azure Managed Redis, to make sure the application is resilient with all the benefit for using an external cache. So this is the name of the library, Microsoft.extensions.caching.hybrid. Check it out. So let's look at the eShop demo. I'm using my Visual Studio 2026. And this is a eShop web application using the .NET framework. I already upgraded it to the latest .NET 10. But just in case if you're curious, if you right-click on this project, there's a modernize command. And if you look into it, it actually provides you with the options for like upgrading to a newer version of .NET or migrate to Azure and explore more options. So these are very handy to get started and automate a lot of the boilerplate tasks for you to upgrade your dependencies yourself, do the evaluations, and so on. For the sake of time, I want to demo this. Let's go directly into the app. So right now, this eShop has a web frontend and SQL backend. If I run it locally, just to mimic how it would behave in an on-prem server, I want to show you how everything when running on-prem, and then you restart it. The session data, for example, could be lost when it's persisted in the local memory. Versus later, we will see in Azure, everything could be persisted in Redis if you add Azure Managed Redis as a dependency to your web application. So making your data external in Redis is not only about resiliency. It could also help you to save cost. for example, when your application really start to receive a lot of user and traffic, everyone's trying to access the product information, and you have a lot of session data stored. At that point, if you save everything in memory, you may have to scale up your web server, versus if you have Redis, it makes your resource more cost efficient, because you're just paying that extra amount of memory that your application uses. Let me see, maybe it's still starting, doing the migrations. Okay, so while this is starting, I want to use the time to show you how our Azure Managed Redis could be securely integrated with the rest of Azure environment. This is actually the Redis version of the application when I deploy it to Azure. You can see among the resources I use, there are things like virtual network, Bastion. This is for securely accessing your virtual machine. And okay, and then so everything is configured securely from the networking perspective. If we go to the Azure Managed Redis resource, we introduce this new networking tab, where here you can configure your public network access. We set it to disabled to make sure it's secure, and private endpoint, we're using it to securely access all the resources, or making sure the traffic from the virtual network can access this Azure Managed Redis securely. Let's take a look at this private endpoint that actually links to a subnet within a virtual network. So this goes to the virtual network. If we look at the subnet page, it has 4 subnets configured, each dedicated to a resource that's used to host the application. So one for database, one for web app, one for cache, and this is my Jumpbox VM for managing the resources. So this allows the web app traffic to securely access both the cache and the database, and make sure the VM could securely access everything that's restricted within a virtual network. Okay. And if we go to the Azure Managed Redis resource again, I just want to show you that you can easily configure the Entra ID by going to the authentication. So Microsoft Entra Authentication tab. In our case, we are using a service principal, which links to the managed identity on the web application. This is the eShop application that's hosted in Azure and uses Redis as a dependency. So say if I view the details for one item and go back, there's a session data just to store what I just viewed. So as a user, I could easily browse to the past viewed items. And this information is now stored in Redis. Sorry. If I go to my Jumpbox here, this is the VM that we saw being part of the virtual network. It can securely access that Azure Managed Redis resource, and everything's done through this nice Redis Insight tool. Here you could see the session data is persisted in the Redis resource itself. And that makes sure the application is fast and resilient. I just want to show you how we did this. So in the application code, Firstly, this is the product service where we incorporated the hybrid cache to make sure repeated database queries are smartly cached. And you can see this is the hybrid cache.get or create async method. What it does is it checks if anything exists in the Redis cache with this key. If yes, return it. If no, it will run this query for getting the information from the database and reuse it for the future queries. And like we mentioned earlier, this supports both the L1 and L2 levels of caching. And it's very easy to add Redis to your application if you are already using providers like the session provider. What you have to do is simply add this Redis distributed cache provider and then hybrid cache session and a lot of other providers can just automatically pick it up as the backend. You don't have to change any code you wrote earlier for the session. Okay. So I just want to quickly go through how you can now extend your application system to be smart and intelligent. Suppose we have an eShop web application that's been modernized. Now you want to build some automated support experience. This is where you can use MCP AI agent, like the Microsoft Agent framework, to automate everything. And because you already know the interfaces and you are already using Redis, you can reuse Redis for a lot of scenarios. So when you modernize your, when you add agent to your overall application system, these are the things you can consider. So firstly, making the agent integrate with the large language models. MCP is the new protocol for querying data and call web APIs using human language. We can see a quick demo later. Add knowledge. So there are things like your product information, your support statement that large language models may not know about. Reusing Redis ensures you can add that additional information to the agent, and this process is what we call RAG, Retrieval Augmented Generative AI. Last, to make sure the whole system is profitable and consistent, accurate, there's a technique called semantic caching, where you can reuse the result generated from semantically similar queries. Like different users may ask questions in different ways, but you want to consistently return the result. This is where Redis can also come into play. It supports vector similarity search to be an ideal semantic cache. And I just want to zoom in a little bit into semantic caching concept. So you see here in this diagram, suppose a lot of customers are asking questions to your application. In this case, if we use a semantic cache, especially when a lot of the answers are preloaded, the application can just hit the embedding endpoint to generate the vectors and then perform the vector similarity search using the Redis resource. If result found, it will just return the result. Notice throughout the whole process, we did not have to call the large language model endpoint, like there's no GPT chat completion endpoint being called. That makes sure your application is cost effective because you don't have to repeatedly call the large language model, which is expensive. And this is the demo we showed earlier for using Redis as an exact question answering agent. So just to see how it looks like. Yeah, if we ask like what is your refund policy, it will first ask me about my name. This is similar to how a lot of agent applications ask for, like, tell me more about yourself, so we could provide a better experience. So I'll just say Catherine. Okay. See, it is thinking. Yeah, so when I ask what is your refund policy, it tells me this statement that's bootstrapped as part of the semantic caching capability. And if I ask it in a slightly different way, like show me your return and refund policy. You see, for questions asked differently, it will return exactly the same answers. And I just want to quickly show you how the code was written. So in this knowledge plugin, we just need to call this one line cache.get similar async, and then pass in the question, so it will search for results from semantically similar questions asked before, or like pre-loaded into Redis cache. The library we're using is the Redis OM. Yeah, and just an overview for how this project works. Basically, the UI itself is the chat service frontend, and we are calling into an orchestration service to make autonomous decisions on which tooling agent to call. In this case, we have the FAQ agent using the semantic cache, and there's another agent for product info agent, which returns the product information. So check it out. Okay.
Great. Well, thank you very much, Catherine. That was great. I really enjoyed it. I love the semantic caching, because that's not actually something that you think about when you start thinking about developing intelligent applications, that you can use Redis kind of the same way that you're using Redis when you're building web apps, and that you're caching the essentially static information, right? These embeddings aren't going to change, and you can kind of just go out and you can check them. So we did receive a question earlier in the in your session, and this one's not super duper. It's related to Redis, but it's not super duper related to what you were covering. But so it really comes down to, why would I use Azure Redis versus like Redis and Docker? When would I use Azure versus just kind of self-hosting it myself in Docker?
Yes, that's a great question. Firstly, like Azure is a very open platform. We know, like for example, if we use Azure Container Apps platform, there are pre-established application patterns to use Redis as a microservice. That is totally fine, and we make sure that the path is going to be still like legit. When you use an external service like Azure Managed Redis, you get a lot of benefit. For example, you don't have to upgrade the version of Redis yourself, versus if you run it in a container, you may have to establish a mechanism to constantly update it, like the newer release just coming out. You think of how you are going to maintain your container going forward. So with the Azure Managed Redis, everything is like, because managed service is automatically patched, is well maintained, and we don't want outages to happen, but in case if support needed, it's a first class support. So there's a lot of like good reasons you rely your system on a managed service like Azure Managed Redis. In addition, if you host this type of dependencies as part of your microservice, I'm imagining like as a microservice in AKS or in Azure Container Apps platform. If something happens to this like application platform, then everything's done. Versus if it's an external service like Azure Managed Redis, it adds an extra layer of redundancy, and it's somewhat decoupled from the application hosting platform. So even if the web application stops working for a few seconds, your data still stays within the Azure Managed Redis. So those are the good reasons I can think of.
Great. Well, thank you very much, Catherine. That was a great session using Redis to really make your AI applications, your intelligent applications, even better than what they were before. So everybody, we made it to the end of .NET Day on Agentic Modernization. We covered a lot of territory. We started out talking about using development tools with agentic tooling built right into them. So like taking GitHub Copilot, app modernization for GitHub Copilot, and bringing your applications from like .NET Framework or a previous like .NET 6, moving them all the way up to modern .NET like .NET 10, .NET 9, and then migrating them up into Azure as well, having that agent tell you what it can do, you know, like, hey, bring it to app service, bring it to ACA. We also took a look at Azure SRE to see the site reliability, to see how it, you know, make sure it's still running, and check for any errors that might be happening. Another agent running to make sure your application is okay and it's up and running as well. And we also took a look at Azure MCP server as well. So it's kind of like your vibe coding within Azure. Kind of just saying, hey, create me an app service, and out it goes. So pretty cool. And then we got into the actual development of applications using the Microsoft Agent Framework, which if you take AutoGen and you took Semantic kernel and you mushed them all together, that's what we have there with Agent Framework, and it's brand new, just released a couple weeks ago, maybe a month ago or so, and pop durable task extensions for functions on it to really kind of give it the durability and also give it a deterministic way to build your agents. And if your agents got rogue, you don't want to have them access any data you want. You don't want them overwriting data or returning data. That's all in the ordinary. Davide showed us how we can set things up with Azure SQL or SQL Server too, to put some guardrails on that. So keep everything nice and tight. And then, of course, we just saw some Redis. Now we can speed things up with Redis for our agents as well. So we covered development tooling. We covered all the agents. We covered some as well. So the full gamut. Of course, check our short link, aka ms/mod. I said a million different ways during this session. You probably saw it a different way in the slides too. They all resolve to the same spot. That's my fault. I gave out everybody a different address just to keep everybody on their toes. But we got it together in the end. Thanks to everybody for doing that. So want to give out a big thank you to all of our presenters today. We couldn't have done it without you, and everybody in the studio who kept this show running. So thank you very much, and thank you to you for watching. And we'll be back with more .NET, more agents, and more AI soon. All right. Thank you very much. My name is Matt, and check out all the sessions and all the resources.